Welcome back to Coding Camp, FTC Coding Camp Day 2. Let's get started.
So first off, we're going to talk about compiling and running code, like Java code. So first off, after a Java source file has been created, so for example, we can use test.java, it needs to be compiled. So the compiler compiles the code in that file to generate a bytecode file, which would be, in this situation, test.class. And this is done using the javawk command of the Java Software Development Kit. So if you did javawk and then test.java, it would compile it and create test.class. So this bytecode file can be executed on any platform, or like any operating system, but it can't be run on the operating system. To execute the bytecode class, or to execute the bytecode file, so test.class, it requires an interpreter, which will convert the bytecode instructions to instructions for the operating system to execute. So the command java test runs the bytecode test.class. So the JVM, or Java Virtual Machine, is the interpreter that can run the bytecode generated file after compilation by interpreting it into machine level instructions for the operating system.
So one of the really cool features about Java was, when it was introduced, it was said, write once, run anywhere. And back in those days, you literally had to write code for each operating system. So there weren't many ways to translate that easily. And Java was one of the first few languages where you could do that. And the reason that's possible is because you have this intermediate layer called Java Virtual Machine, which sits between your program and the operating system. And you get a different JVM for each OS. So depending on the operating system, the JVM has the ability to convert your code into the right kind of instructions for the operating system where it is running. So we just want to make sure that you understand there's this layer called JVM sitting there. From an FTC coding perspective, you shouldn't really be affected by this. But please know that there is a JVM sitting there on your control hub also. And that's what allows for the Java code that you're writing to be executed on the control hub. So in this case, it would be a version meant for the Android system, Android operating system. And the commands which you see here, javawk and Java, these are command line commands, which, you know how we spoke earlier, if you want to install JDK 17, you could do that. So if you were to do that, that's when you can go into command line and execute these commands. So if your intention is to go deeper into Java and learn more of the low-level aspects, then please definitely do that. So this is just a quick window into that you can go into. And there's one more reason we wanted to show this. And Ron, if you can go ahead and cover the next slide, we'll talk about that.
So Gradle. The most common processes in building any software include compiling the source code and packaging that compiled output to a compressed format like APK or Android package. Or other examples include jar, tar, and zip. We might also perform some other tasks like publishing the artifacts to some repository or transferring the APK to the Android device. If there is no build tool to automate this process, then we will need to perform all these actions manually, which would be slow and have chances of human errors. So Gradle is the build tool used in the FTC SDK to automate all of these processes.
So in the previous slide, you just saw how there was this Java, and then the name of a Java file. And then when you wanted to run it, you had to type Java and then the name of the class file, right? So just imagine if you have to do that for every single Java file, that's a long, tedious, and error-prone process. How do you avoid that? That's what tools like Gradle come in for. So one of the older kind of tools that we had which achieved a similar thing was called Ant. And then came Maven. So Maven is still popular and still used widely in the industry. And then Gradle is one of the more recent ones, which all serve the same purpose, which is make you not have to run all these commands, command line commands by typing them out. Instead, it does that all behind the scenes for you. Of course, you have to set it up, and as you can see, all those file names there, like build.gradle, build.dependencies, and so on. So those are examples of files which are included in your FTC SDK. And there will be some rare times when you will have to go in there and make modifications. For example, if you want to add a third-party library, like Roadrunner is a popular one. If you want to add Roadrunner, at the end we'll get to what Roadrunner is, but it's one of those situations where you will have to go into those files and make small modifications. But those instructions will be provided to you by whoever the third-party library maker is. So it's not something you have to figure out. So don't worry about that. And then just to quickly touch on a couple of those topics there. So when you build your code, you've generated a set of classes, and then you need to package them together. So jar, that actually means Java archive. And at work, you know, a lot of times if you speak to your parents who are working with Java, they may talk to you about jar, because that's a popular way of handing out third-party libraries for Java or applications in Java, you know, for distribution. And then APK. So in this case, the FTC SDK ends up building a mobile app, and that mobile app is what is downloaded into your control hub, right? The extension for these apps is APK, Android package. In fact, if you have Facebook on an Android phone and you dig in there, you will find Facebook.apk. And that's what Facebook built and made available on the Google Store for anyone who has an Android phone to be able to download it. So you are building an application just like that. And it would be an APK file which gets downloaded to the control hub. And in order to do that, it's going to require a bunch of commands beyond just compiling and creating your class file. So those commands, they are all put together behind the scenes in Gradle. But you as a software developer for FTC, you will not have to work with the actual commands. In Android Studio, there's going to be buttons where you hit build, or you can hit one. And what that does is all these things. It's going to compile the code, package it, and then download it to the control hub. And only after it's successfully installed on the control hub, you get a message indicating that, yes, your code is now ready for execution. Whatever changes you have made in Android Studio are now available on the control hub.
Can you, Andrew, I think you have a question.
Andrew, please
go
go.
ahead.
It's kind of hard to hear you. Just want to let you know.
Oh, thank you for. I'm going to stand here and talk then. Okay. Is this any better, Andrew?
Yeah, that's much better.
Okay.
Yeah,
all
it is.
right. I will do that. So is there anything that I just spoke about that you would like me to repeat? I want to make sure all that information was still audible.
Just like the last sentence you said was really muffled.
Okay, all right. So let me repeat that. So what I was saying is, as a person who's on the coding team, who's going to be writing code for FTC, you do not have to worry about running all these commands like compiling Java code or creating the APK package. So all these things will be done through the user interface in Android Studio. So you will have buttons for building, and then you'll have a button to download all that code into your control hub. But it's just good to be aware that when you click that button, there's a few different commands that get run and a few different things that happen. And that's all done by Gradle. And so we wanted to just make you aware of that part. Okay, Ron, you can continue from here.
All right, so so you guys are all expected to know Java, but it is just like, in case you don't know too much about object-oriented programming, there's just like a really quick overview. So basically, object-oriented programming involves classes and objects along with their attributes and methods. Java is a programming language that uses object-oriented programming. So as an example, in real life, an apple is an object, and it is an instance of a fruit, which would be the class. Just a second. Yeah, the apple has attributes such as weight and color, and methods are what can be done by the fruit, such as grow and rot. If Jill, an object of class person, is eating the apple, then eat is a method that the class person has. A class is like an object constructor or a blueprint for creating objects. The following illustration shows the difference between classes and objects. So for example, if the class is a fruit, then objects under it could be apple, banana, or mango. Does anyone have any questions?
So just to say a few more things about that, the ability to differentiate between what a class is and what an object is going to be probably one of the more important things you need to feel comfortable about as you get into code. Because the class, like is mentioned, it is a blueprint. It indicates how it should be or what all abilities it should have, like what all attributes can it have and what kind of behaviors can it have. But an object is an actual instance of that. See, a person, right? We all know a person might have a name, a person might have some age, and they may have a certain height, different attributes about a person. But then when you talk about a specific person, that's when you have actual values, because that's an actual person. And the person has a name, in this case, Jill. So the same way, when you're writing code, you are writing classes. But when it's executing, it's going to create objects, which are instances of those classes. And the way you write code, in the sense, the way you instantiate an object from a class, and then in what cases you can access methods or attributes on those objects. And in some cases, you will be able to access methods directly from a class. So being able to differentiate that, it is good if you can learn that part. And at the end of this presentation, we have 2 pages of links. And also, I think we had sent that PDF, a link to that PDF file, which is Java for FTC. So please make sure that you get familiar with at least that much Java so that all these concepts are easy to understand as you start coding more and more complex things with what you've learned here yesterday and what you'll be learning today. Okay, all right, please go ahead.
All right, so now we're gonna actually start coding.
I
So
think before this, we want to import the FTC.
yeah, that's right. That's what I was gonna say. So if you all remember, yesterday we downloaded the FTC SDK. So I'll show you guys like.
And while Rohan's navigating to that, just wanted to add that I think at this point, everyone was able to get GitHub set up, and so they should be able to push code. But if there's anyone here who joined only today or couldn't get things working yesterday, what we're doing today, other than being able to push code back to GitHub, everything else you should be able to do today. Okay, so you will be able to write your code, run it. As far as downloading it, if you have electronics of your own, then yes, you will be able to. So maybe now is a good time. Is there any attendee who is on Zoom who has their own electronics and intends to run the code on that control hub or other hardware that you might have?
What'd you say?
I was asking if there's anyone on the Zoom call who intends to run the code on their own electronics. Like, do you have your own control hub available? And I see one hand up. So Nathan, that's great. So what we're going to do is keep showing, we'll focus the video on exactly what the connections are and so on. We have a team here in person. They also have brought their own electronics. So we'll be doing this as a, something together. Is there anyone else who has their own control hub and wants to run the code? And it's totally fine if you don't have your own electronics, because we will be showing the behavior with a set of electronics that we have here. So we have a drive chassis. We're going to connect motors, servos, and so on to that and show you how the code works. So with that said, let's go on to the next step, which is getting the project opened in Android Studio and have it running. So you can go ahead.
Yeah, so Kevin, I see you have a question about simulators. Yeah, so wait, Harry, did you want to talk about that?
I don't think there are.
Yeah, there's
I don't know.
we haven't really heard about really any good simulators for testing code.
There is FTC sim. So there is one team in Canada that has created FTC simulator. So we will send you the link for that. I can't recall if that was part of the links at in those 2 pages, but yeah, we'll share that in message to everyone here in a moment. And we'll make sure we include that in the slides before we share them.
Okay. All right, and then well, one more thing to talk about though is that if you're using Roadrunner, there's something called Meep, which is really good for like testing your autonomous code like from Roadrunner. So that's another one called Meep. I just like type it out. It's kind of weird to say, but yeah, that's like, and this is there's the documentation about this it's the same place as the Roadrunner documentation. So we'll get to some of that like later today. Yeah. Okay. All right. So now, yeah, we'll open our code in Android Studio. So basically to do this, what we need to do is first open Android Studio. So click on that. And then, all right, your guys' screen should look something like this when you open it. Depending on if you use Android Studio in the past or not, you won't have any projects here. Yeah, but just like raise your hand or something when you guys are all at this screen. You can see this. All right, perfect. Micah, and then and also feel free to ask me if you have any questions.
Mine doesn't have that screen.
All right, what does your screen look like when you open Android Studio?
Never mind, it was just loading.
Okay, all right, that's fine. All right. All right, so Nathan and Ella, are you guys at the screen yet, or do you have any if you are having some problems, like you can just let me know, and I can help you out. Okay, all right.
When I open it, it doesn't show what your screen shows.
Oh, okay.
If you don't have any projects open, it might look something like.
Oh yeah.
what I'm
If you look
showing
in the
now.
camera,
Oh,
yeah, it might.
No, it's
Right.
like in projects or something.
Does it say
Oh.
something like welcome to Android Studio, create a new project?
No, it says like search everywhere, double shift, project view, alt 1, go to file, control shift N.
Okay, all right.
That's cool.
Yeah. All right. We'll have you share your screen really quick. That might make things a little bit easier. Yeah. So, oh wait. Let me. Oh yeah, Nathan, you should be able to share your screen now.
Oh,
Oh,
okay.
it's okay.
You have to, I think, yeah, you already have it open.
Oh yeah, I guess you're like kind of ahead of
You're,
us.
you're kind of ahead, you already have
Yeah.
it. You already
Wait.
have it
Click on project really quick, like on the left.
open. Yeah. you
Okay.
already
All right.
have it set
Perfect.
up.
You already like finished this step, so yeah, you're good to go, Nathan. You're
Okay.
like ahead of us. All right. Yeah, you can stop sharing. Yeah. All right. And then, so Ella and May, do you guys need any help? Or,
Yeah, I'm stuck on the welcome screen.
okay, all right. I'll have you, well, all right, wait, when you say the welcome screen, does it look like this? Like this screen?
It might not have.
No, it just says welcome to Android Studio.
Yeah, that's
Oh,
correct.
yeah. Does it
You
have
don't
like a
any
big,
projects.
yeah, does it have like a big plus button in the middle?
Like,
It has a plus button on the side.
Okay, all right, yeah.
That's what it should look like. That's what mine looks like.
Yeah, that's, you should be good too. All right, and then, May, do you need any help or? Yeah,
So Andrew and Nathan have raised their hand because they're done, is that?
yeah, everybody's done except for May, I think.
So, this is, the purpose is to open it up, right? That's what they're trying.
Yeah, yeah, so it's basically just getting to the screen and then we go. to the
Are
next
you
step.
helping May right now? You can ask her to share screen and then. Well, I mean, check a couple of times and then.
Yeah.
let's-
May, are you able to hear us? I can,
Yes, I need to install Android Studio.
okay, all right, I see. In that case, just let us know when it's done installing and then we can get back to you.
Right,
Alright.
and depending on the internet speeds, that might take some time.
Yeah,
So, you please, go ahead and let us know once that is done. We'll keep proceeding, just getting everyone to open the SDK and, hopefully by then it'll be done.
all right, so now, all right, so I think in that case, we can move on to the next step. So this,
I need to download the FTC robot controller.
oh, you still, okay, all right, in that case, I'll send a link in the chat. Just a second, yeah. So yeah, so I'll send you a link in the chat to get to that. All right, yeah, so Ella, just open up the link I sent you in the chat, and then I'll tell you what to do from there.
Okay.
Alright. So yeah, so let me know once you have the web page loaded.
Okay.
Yeah, all right. So now, all you want to do is you can, do you see the source code .zip? Just click
Yes.
on that. Yeah, just click on that and you can go to downloads and just download it there. So yeah, you can just download in downloads. Yeah, so I'm
Okay.
gonna cancel because I already have it downloaded. Yeah, but yeah, just do that and then let me know when it's done. And you will also have to unzip it. So actually, no, I'll just download it to show you. So, yeah, all right, so you'll click save and then you can see it like popped up at the bottom of my Google Chrome window. So yeah, so you just have to click on that and it'll unzip it. Yeah, so let me know once that has finished loaded and we can move on to the next step.
Now, unzip it. Do you know if it automatically unzips on Macs?
Well, I'm on a Mac right now and I have to actually click it in the bottom of my like Google Chrome window. I have to click on that and then it'll automatically unzip it.
Okay, it looks like it automatically unzipped it.
Okay, all right, that's good then. All right. Then in that case, I'll get back to Android Studio. Yeah, so all right. So are you ready to move on to the next step in that case?
Yes.
Okay, all right. So yeah, so somewhere on your welcome screen, you should see an open button.
It should be the middle button.
Yeah, for you guys might be the middle button.
It'll be right,
Yeah.
and it'll have like the folder icon.
Yeah, it'll have a folder icon. So basically you're just gonna click on that open button. Yeah, and it should bring up like a Windows Explorer window or a Finder window. Yeah, so once you have clicked on it, then you just want to like navigate to where you downloaded your FTC robot controller. So which one is it? Is it master? Yeah, that's right. Yeah, so you guys should see something that says FTC robot controller 8.2. So then once you see that, just click on it and then click open. And yeah, you want to just trust project.
I don't know where mine is. I thought I downloaded it into download, but I don't see it there.
Okay, all right. In that case, I'll have you share your screen and we'll try and find it.
So whoever's raised their hand has already managed to open it.
Well,
I found it.
Okay, you found it. All right, perfect. All
So
right.
yeah, please raise the hand if you have managed to hit open. And it might take a while. It might do a bunch of
Yeah.
things before it shows the folder structure on the
Yeah.
left-hand side.
Yeah, I'll share. my
So I
screen.
just click on the folder and hit open.
Yes,
Yeah,
and you see how on the left-hand side, there's 3 folders. Can you expand, FTC robot controller? So you might see loading there, and it may not be showing all the subfolders.
yeah.
It'll take a while because it's doing the initial build. So please let that continue. And once the initial build is done and you see the folder structure, then please raise your hand.
Yeah. All right, Andrew, you're good. You're good. All right, so, it looks like everyone has their hand raised. Does that mean you guys all, are at this point? Or it might still be loading, but like, yeah, if anyone is not at this point yet-
Sorry, no, I cannot. I'm on Windows, so it looks like completely different. And I am having trouble locating my files.
Okay, all right. In that case, I'll have you share your screen so I can help you out. So yeah, you should be able to share.
Okay. I think it just made this even worse. Okay.
All right.
Yeah, I clicked some buttons and now I'm here.
Oh, okay. All right. So I think I see the issue here. So yeah, yeah. Click on file, like in your top, like in the menu.
Okay.
Yeah, and then click close project. Yeah, close project.
Close project.
Okay.
Yeah.
Okay.
I'll click open
Yeah.
again
Click open again
on the right.
on
Top
the
right.
right side. Yeah.
All right. Oh, there.
Yeah, I think you open your whole like
User
folder,
folder, yeah.
your whole user.
Okay,
folders,
so what
yeah.
you need to do is click on the arrow next to Micah to
Yeah.
expand the folder. Yeah.
Yeah, you can.
It doesn't do anything though.
Click it and then wait. It might
Yeah.
take it. Just click it one. Okay, now
Yeah,
wait.
just like it. Do you remember exactly where you downloaded your FTC robot controller?
It might be in the other.
Okay, yeah.
Oh,
there
it's
you go.
in it's in
Yeah.
sure. It's in the other user folder.
It's here.
Okay,
Yeah,
Android.
it's there, it's right there.
I know. Go back to Android Studio. Okay, try clicking on sure. Oh, whatever you're.
Oh,
Yeah,
yeah.
I don't think it's Micah.
Click on sure.
And then click on the arrow
Like
once.
there, yeah.
Yep.
Oh,
So
here.
click on
on downloads.
expand. Click on the arrow next to downloads.
Yeah.
Okay, and now click on FTC robot controller. It's the first one.
Yeah, right under
You scroll
downloads,
past
up.
it. Yeah, scroll back up.
I did.
It's right under
Right under
downloads.
downloads, yeah.
At the very top.
Oh, I was looking at.
All right,
Okay,
and then
can
now
you
just
click on click on the arrow and now click on the
Oh yeah.
this one, the one with the Android, the green logo, the green
That?
one. Yep, and now click open. At the block.
Okay. You mean okay?
Click okay. Yeah.
Okay.
Oh no, I think I know the problem. Can you just like close out of Android? Do you just close it?
Close it all.
Close it all.
Okay.
And then open it back up.
Where did I?
Open. Yes, just search for it.
Android Studio.
Yeah. Yep, okay, now, you didn't finish doing the setup, so, just click next. Click next. Click next. Click next. And then now click on the accept button, like,
It's bottom right.
yeah. And then click on the, like, what do you call it?
The
Like the
slider, or wait, yeah.
red dot.
Future Martins, you can ask remote control. You can ask for remote control.
Oh yeah, we'll do that. We'll do that.
Okay.
Remote control.
Okay.
Yeah, you.
You right click it. You right click the person.
Yeah,
We have it.
Okay.
Okay, so you click on accept there. And accept. Now click.
Oh. Okay.
Okay, I will stop remote control. Okay,
Yeah, all right,
and now you need to wait for it to download.
yeah.
Don't worry when it starts looking like it's having a seizure.
Yeah, it's just a lot of files.
Okay.
Yeah, we had that issue yesterday.
So at this point, so Micah and May, I don't see their hands raised. Are they still?
Oh,
getting-
May is
Micro's the one doing the
downloading.
setup right now.
Yeah,
Micah
we're
is
helping
doing the
Mike
setup,
right now.
okay.
May is downloading Android Studios.
Okay, download.
Android Studio.
Hmm.
Alright, so May, how has your progress been on downloading Android Studio? Is it done yet, or like where are you at right now? May, can you hear us?
Same as the screen you are showing downloading component.
Okay, all right. That's good. All right. So yeah, just let us know when you're done with that, and then we can show you the steps. Yeah.
So for everyone who has their hand raised, quickly asking if the word loading is gone and you're able to see the photo structure. If you leave your hand raised, then we'll interpret that as, yes, the word loading is gone and you're now seeing the photo structure. Okay, that's good, right. May I just update you on the progress?
Yeah, she said she's like downloading components.
Okay, so just hit finish now.
Yes.
Yes.
Yeah, there you go. Alright, now click open.
Uh,
Yeah.
Top. Yeah, and then just click and click OK. All right, there you go. Yeah, you should be good to go. It's just gonna it'll take like a little bit to load, but yeah,
Okay.
other than that, it should be good.
So when you see the word loading, what it's doing is it's running. So you do want to
Oh, yeah,
allow.
click allow access.
Allow
yeah.
access. Hold on. So public, no, that, I was just going to say, for public, do not have it checked, but for private, do have it checked.
I don't really use a lot of public internet, like
Okay.
ever, so
Okay, all right, then fine.
it won't be the end of the world,
Yeah,
hopefully.
yeah. No, I mean, if you don't really connect that.
Okay, next.
Yeah,
Alright,
this
just
tips
click-
you
yeah,
can
you can click
close,
close, yeah, there's-
and at other
there.
times you can hit next and learn more of those.
Yes, yeah,
You can hit close if you want to close.
yeah.
The close, yeah, right. There.
All right. So May, has Android Studio finished downloading?
So how did Meep come up there?
It's like a simulator. Is it missing?
It's a path simulator.
I know, I talked about it,
Yeah.
but it's like if you can't test your Roadrunner stuff with the robot, you can use that.
Okay, so is that May's screen? you're seeing?
Yes, okay. All right, yeah, thank you for sharing your screen. All right, so it looks like it's still downloading. All right. Yeah, we'll just you can just keep sharing your screen and then we'll wait for it to finish downloading.
So everyone, thank you for your patience. We're just going to wait because otherwise, that person will not be able to continue following. So we'll just give it Actually, if everyone want to take a 5-minute break, now is a good time, because I think after the break, once we start coding, we'll go longer. So everyone feel free to take a 5-minute break.
Even like.
Thank you.
Okay.
We gave everyone a 5-minute break.
And they also have their
I'll just show you how to do it. Now you select your system.
Yeah, or yeah, that's right.
If we can sit down. Yeah. We're gonna get a picture just for our. Yeah, we'll just get you on the edge.
Okay, all right, so May, it looks like, yeah, just click finish. Yeah, perfect. Yeah, now click open. And then, yeah, expand Erica, yeah, and then scroll down, yeah, click on downloads. Yeah, and then, yeah, click on that one and click OK. All right. Yeah. All right, yeah, perfect. All right, so yeah, it might take like a little bit to load, but you should be in the same. Oh yeah, just click. Yeah,
Private,
click.
allow it on private,
Yeah,
because
allow.
then you'll be able to wirelessly download code.
Yeah, there you go. Yeah, and then
So,
click
I'm not-
allow access.
Interesting. Once you do this initial, did you guys get that?
All right, there you go.
Wait, you selected private. Hold on. You can-
All right, excuse me. All right, yeah, you should be good to go. So I think everybody should be at this screen now. So we can get started on actually coding. So that's pretty cool. Yeah. All right, so yeah, so let's look at this slide. So basically when you want to download code, we'll show you how to do that.
Okay, so maybe let's quickly talk about a couple of locations, right? So you need that to be done. So yeah. So now that you either have already managed to open up the entire folder, or it's probably in the middle of showing loading here momentarily. So there are two really important locations that you should be aware of. The first one is where you are going to be writing all your custom code. So,
Wait, that's.
oh, you have that later?
Yeah.
Okay, right.
Okay.
Right, we'll cover this here
Yeah,
shortly.
so, first up, right now we're gonna cover just downloading code. So basically, when you do this, you need a table. So basically, you need a. All right, if you're on a Windows, you don't need the adapter. You just need a USB-A to USB-C cable. So basically, you connect the USB-C end into your control hub. It's like the same place we connected it yesterday for web hardware client. And then you just connect this end into the computer. Like that. Yeah, just like that. But then if you're on a Mac, if you're on one of the newer Macs, you would probably need this adapter.
Kind of hard to hear.
Oh yeah. Forgot about that.
Can you switch the mic to be on the camera?
Yeah,
Yeah, you should stop sharing and spotlight the camera.
yeah, that's it. Okay. Oh yeah, so I'll show you really quickly again. You connect one end into the control hub right here.
That's the USB-C in.
Yeah. And you connect the USB-A end into your,
If you have a regular USB port, then you can connect it directly into a regular USB port. But if you have only USB-C ports, like some Macs do, then you would just use an adapter and connect it there.
yeah, just like that. So, all right, now I'll share my screen again.
One more point to add here is we strongly encourage you to use the orange cable that came with your system, because there are really two kinds of cables. One is a data cable, which can also do charging, and the other is a purely charging cable. So if you use a purely charging cable, it will not transfer data on those. So if you have a cable that came with the control hub, which is typically the orange colored one, please use that.
Yeah, all right. Now, wait, you can put the web there. All right, I'll start sharing my screen now. All right, yeah. So now you can see here. All right, just a second. Yeah, you can see this at the very top here. It says team code. Sorry, just a second. I'm gonna minimize it. Yeah. You can see it says team code, and then we didn't. Oh yeah, all right. One key thing we forgot to do was actually turning the robot on. Yeah, you need to do that. That's pretty important. Yeah, so while the robot's booting up, this will change. Yeah. So yeah, now it's Rev Robotics Control Hub. This means that you're connected to the device. And so when you want to actually download the code, all you have to do is click this run button and it will download it.
Is there something that I missed? I just got back.
Okay, how long were you gone?
From when the break ended.
Yeah,
Okay, you can just show the connections.
okay.
Show the connections.
Yeah. All right, yeah, we'll just show you really quickly again. So
Okay.
yeah, basically, all you missed was we were just showing you how to connect to the control hub to actually download code. So basically, what we have to do is, you connect the USB-C into the control hub right here, and then into your computer, you just connect the other end. Yeah, right here. Yeah, so for me, because I'm using a Mac, I only have USB-C ports, so I had to use an adapter. But if you're on a Windows or any computer with a USB-A port, you can just connect this directly into it. Yeah, so that's, and now I'll share my screen again. Oh yeah, I think it should be fine. Like, if I share my screen. Yeah. Oh yeah, so now you guys should see the shared screen. Yeah, so you can see how up here it says Rev Robotics Control Hub. This means that it's properly connected to the device. And then when you want to download code, you just press this button. So the first time I pressed it earlier, it was like, it looks like a play button. That's because it was the first time we downloaded code. But now pretty much every time it's gonna look like this. Okay, all right. So now let me go back to the slides. So yeah, so we covered downloading code. So next up is navigating the SDK. So basically, all right, I'll go back here. So when you're actually writing your custom code, you want to go to the team code. Yeah, let me just minimize all these. Yeah, you want to open team code, Java, and then in this org.firstinspires.ftc.team code, this is where you will like write all your custom code. So you just like right click it and then new, and then just click on Java class, and you can name this whatever you want. So we'll name it first program. Yeah, and then all right, and then if you had your GitHub repository set up from yesterday, you should see this pop up. So you're pretty much most of the time you're gonna want to press add because you want your teammates to see like the new program you made. So yeah, so if everybody can just like right click this and then new and then Java class and then name it first program. Yeah, you guys can just do that and then like raise your hand when you're done.
Okay, guys.
Yeah.
Could you repeat that again?
Oh yeah, I just said if everybody could just open the team code and then Java and then this and then right click this and then new and then click on Java class and then just name it first program and like press enter, then you guys should see this screen. Like that's how you will create a new program every time you want to do that.
I don't see that.
All right, I'll just have you share your screen. I think that'll probably be the easiest. So yeah, so yeah, just like share your screen and I'll try and help you out.
Okay, I got it. I found out.
Okay.
We're good.
Okay, all right. I'll share my screen. Yeah, if anybody else needs help, I know I kind of went through that a little bit quickly. So if anyone else needs help, just let me know. Alright, so I see Kevin, Nathan, Ella, Micah, and Andrew. You guys all have your hands raised. Does that mean you guys have completed this step and your screen looks like this? Okay, all right. All right. Oh yeah, May, how is are you at the, oh yeah, I forgot. Never mind. You already downloaded your Android Studio. Yeah, never mind. All right, yeah, Nathan, you're done. All right. Does anyone else need help with this? All right. All right, so is anybody not at this step? Has anybody not completed this yet? Okay, all right. Nobody said anything. That means I'm gonna assume that everybody is at this step. So now I showed you guys where you write your custom code. So now I'll show you guys one more thing. So if you open up FTC robot controller and then Java, not the Java generated, just normal Java. And here you see external samples. So all of these are sample programs, and basically they're very helpful because you can like learn how to do stuff such as oh yeah, let me go. Yeah, here, sample code. It's a very powerful resource because it provides examples of various coding applications such as moving a motor, vision processing, etc. Yeah.
Excuse me,
Yes,
can you pause real quick? I'm gonna do something.
like stop my share or like just like what do you mean by pause?
I think he means stop.
Okay.
Almost done.
Alright. Yeah, just let me know when you're done.
The robot controller, where did you original get it from? Is there any update from time to time?
Yeah, there are updates, but I don't think there's like an update today, if that's what you're asking, but yeah, like every few months or so, there might be an update. Does that answer your question?
Is it on the first Inspire website?
Oh, yeah, if you check the chat, I sent a link to it at 1:30. So you just like click on that and that should take you to like the website. And I don't know if it's it's on GitHub. Like you search up FTC robot controller on GitHub. That's where we got it from.
Are you guys doing good? Is there anything you need? So how far along are you guys?
We're like making the first program and I showed them sample code.
Sure, the sample code location. Yeah. So the sample code location is really a great resource to learn from, because you have examples of how to write code for almost everything that comes out of the box and a whole lot more. You have code there for moving motors, servos. A lot of what we're doing here is already in the sample code. So please remember to go through the sample code in detail, using of any kind of sensor, and even drives like tag drive versus mechanism drive. They have code in there for that as well. So as you'll see, a lot of code that we end up writing here, you would have also found it in the sample code.
All right, so I think May, are you like, have you finished this step yet? Have you made like first program? Yeah, then you have all these.
Yes, just the empty first program, right? Empty.
Yes, empty. Yeah, it should
Yes,
look
yes,
like
I did, yeah.
okay, all right. In that case, we'll move on to actually writing code. So, all right, so right here, we can go next slide.
So let's make
So
sure.
yeah, all right. So first, I want to talk about the stages of a program and the two different off mode classes. So basically, the FTC SDK offers two off mode classes, the linear off mode and off mode. But in this camp, we'll mainly be using linear off mode. So yeah, if you want to like later on research more about just off mode, you can do that. Yeah. All right, so there's two main stages of a program. There's the initialization stage, where you run all the things necessary to set up your robot before pressing play, such as your motor configurations, webcam setup, etc. And then the start stage is where you like have your actual code for moving motors or for your teleop, like mapping your like controller buttons to certain actions. Yeah, so are there any questions? And just like speak out loud, because like I think some people have their hand already raised from previous slides.
Yeah, you can lower your hand and we'll ask again if there's.
Yeah, all right, so now you can just raise your hand if you have any questions.
So Andrew, okay.
Okay, Kevin, yeah, go ahead.
So Kevin, if you have a question. Okay, all right. So one thing we wanted to add here is just the importance of understanding the difference between the initialization stage and the running stage of the program. Now, as you may already know, or as you will find out, there's a requirement that the robot should not exceed 18 inches by 18 inches by 18 inches in any of the three dimensions, right? And along with checking for that during the robot inspection, they also require that to be true in the initialization phase. So as you'll see here shortly on the driver hub, when you select a program to run, the first thing that happens is it goes into an initialization, init phase. So that's the phase or the time frame between when you selected your program for execution, right? And you clicked on init and you're waiting for the timer to show that the game can start. So it is the few seconds just before you hit play and the game starts. And during that phase, between when you press the init button and till you press the play button, during that period, it is required that your robot does not exceed 18 by 18 by 18, which means if you have an extending arm or something like that, it needs to be pulled back in and stay under 18 inches in all 3 dimensions when you click in it. Now, there may be some robots where you have a part that is just loosely hanging out, and in your init phase, you can kind of curl back in under 18. So you can actually execute code in the init phase to make sure that everything comes back within 18 inches. And then after you hit play, it can go back and expand as necessary, depending on the robot you designed. So please remember this, your robot should not exceed 18 inches in length, width, or height when you hit init. When you hit init, it should stay within 18 inches. When you hit play, that's when it can expand and go beyond that. And also during inspection, you should show that it is under 18 inches in all 3 dimensions. Let's see, what else? And during init phase, a lot of things like initializing hardware. If you have a sensor, you need to initialize. Initialization simply means you're making the control hub aware that, okay, there's this particular kind of sensor. It may be a touch sensor, it may be a color sensor. You're making it aware that there's this sensor, and let's do whatever is necessary to be able to start using it. And then when you hit play, at that point, it's ready for usage. Yes, Kenny, you have a question?
Are we supposed to type this code?
I'm sorry, are you supposed to?
No, not yet. I'll get to that later. Yeah, you guys don't have to type this code yet.
Oh, right.
Okay.
Sorry, we were just explaining the difference between init and play because it's an important part of starting off. Yeah, from here you can take it.
All right. So now we've covered this. So now, we'll get to what this code is. So if you remember, I talked about how there's 2 op mode classes. This is basically how you decide which one you're using. So if we go back to our program right here where it says first program, you just want to type extends linear op mode. Yeah, and then now you will get an error, and this is like good. You want there like we'll get to like how to fix this error later, but yeah, you should have an error here. Yeah, yes, Andrew.
Never mind.
Okay, all right. Yeah. All right, so just like speak out loud when you finish this, like just say something. And then
Can you put that in the chat?
oh yeah, sure. So extend wait, let me retype that. I forgot to make the E lowercase. All right, yeah, there we go. So yeah, so the second thing, you can just like copy paste that right after your like first program.
Which one, the second one or the first one?
Second one. Oh yeah, let me delete the first one.
Can you zoom in because I think it'll be much easier to see that.
Yeah, it's definitely. Or not? Oh yeah, there we go.
Do I hit enter or something?
Yeah, you can like hit enter. I don't know, you shouldn't have to hit enter, like just like basically type whatever I have here, like. And then so for the import, for me, when I type this, it automatically adds the import, but for some of you, it may not do that. So I'll copy paste this import into the chat just in case. So that way you guys can pretty quickly like just put that in. So yeah, so I put the import in the chat. So if you guys didn't automatically get this import, just like look at the chat, copy paste that under package.
And also just remember, if you have a red line underneath your public class first program, that's good. You should have a red line right now.
Yeah.
And just to remind everyone, import simply means you will be using that particular class in your program. So you're asking for that to be imported in. And if you don't have the import, then in your code, it won't understand what linear op mode is, and it's going to throw an error. And that's why you add an import.
I don't have a red line under the text.
Oh.
Is that a problem?
Well, okay, do you have something that says like run op mode?
So some of you may have already clicked on the error
Um,
message and asked it to
Wait, so-
implement required
wait,
methods.
Wait, sorry, what was that, Micah?
Let me just share screen real quick.
Yeah, just share your screen. That was probably easy.
Yeah. Okay. This is where. I'm at.
It's because, okay, all right, it's because, a couple things, so. Your linear alt mode, the L isn't capital, you need to make sure that's capital. So yeah,
Oh,
so
okay.
Java is a case sensitive programming language, so you need to make sure like
Just press
it's like, just press escape. Very cool, yeah, just
You can click outside that box.
click out.
Huh?
Yeah.
Yeah, alright, just make sure there's a space between that bracket and linear alt mode.
Oh, okay.
Oh, wait, oh, yeah, oh, okay, never mind, that doesn't matter, alright, yeah, you see where you have like the com.qualcomm, make sure you type import before that, so like, just go to that line number 2, click on that, yeah, type import and space.
And
Yeah,
also,
there you go,
Oh, okay.
yeah,
Okay.
one word of advice, the first line is always the package. Leave the next line empty and then have the import starting on the third line, just so that you separate out your imports.
Yeah.
They made the
Okay.
FTC robot controller not team code.
Oh, right,
Oh,
okay.
Yeah, it was
okay.
the pack- the power-
So call that
Alright,
out and make sure everyone.
Wait, can you share your screen again, Micah?
Sure.
Good catch.
Here you go.
Oh, okay, alright, so I think you might have made your program in the wrong spot. So if you just like, just click on like, you see FTC robot controller, like the
Wait,
down
before you do
arrow.
that, can you please select your, wherever your file is? On the left-hand side, if you can scroll down, what was the name of your file?
First.
This. Here.
So I don't see,
No, not
Oh,
there,
that
no,
was-
yeah.
okay,
Oh,
so,
okay,
so
alright.
please right-click on that
Yeah, right click that.
and then cut.
Yeah, you just do-
And now, if you can please go down, where you see team code, expand team code. Yeah. So that's where all your custom code is going to be.
Yeah,
The
so.
Okay.
Java, if you can expand Java,
Drop down.
Expand Java. Okay.
Yeah,
then, where it says, or wherever readme is, the one above readme.
Yeah.
Right click on that, please, and then click on paste.
Yeah, and click refactor.
Yes, please select refactor.
Yeah, there
So
you go.
please remember that all your custom code is going to be written here. The earlier location, that's where the sample code is located. So just use that to go check code or copy code and use it, but please don't create your code over there. You want to be creating your code where it says org firstinspires.org FTC team code. You can create subfolders under team code, but don't go outside of team code for Java code.
Alright, does anybody else need help with this step?
Wait, did everything else?
I think I may have done something wrong.
Okay, alright, I will just have you share your screen then. Yeah, so yeah, you can go ahead and share your screen.
And Micah, please let us know if, everything looked good in terms of the import, the package. See, the package should say
Okay,
org first inspires FTC team code.
So
Alright,
there's a missing curly bracket and the second import is unnecessary.
yeah, so I'm just gonna like quickly request remote control, just like accept really good. Yeah, okay, alright, so. Alright, basically, yeah, what you have to do, so yeah, this
The
import,
second import
yeah,
isn't necessary.
yeah, you
because
don't-
already
yeah.
imported it. And usually you don't do imports inside a class.
yeah.
Imports are always outside and typically right after package.
So yeah, so basically
And-
what you need to make sure you had the two curly brackets and your import, you already had your import up here, so you didn't need it. You didn't need an additional one. And also, always make sure that you never put your imports like in the class. Class, you always put your imports like underneath package. Yeah,
Okay.
alright, yeah, there you go.
Uh,
So, alright,
I think
this,
Harry has something. Harry, go.
No, I was just saying stop the link.
Oh.
Yeah, the button.
alright, does anyone else need help?
So you can share your screen and then you guys can proceed.
Okay, alright, yeah, in that case, yeah, we can proceed to the next step. So we finished this. So now it's writing our very first program. So, all right, so we already extended linear op mode. So yeah, so now the next step is to get rid of this error. So basically just like, kind of just like watch my screen and follow along. But all you want to do, it's pretty easy. Just hover over that red line and you should see this, and you should see an implement methods. So then, all right, once you see implement methods, hover over it and then click on it. And you should see this screen pop up and then just click OK. Yeah, so basically I'll just like do that again, show you guys. Hover over the red line, click on implement methods, and then click on OK. Yeah, so once everybody has done this step, just raise your hand. And also if you have any questions, just let me know. Okay, all right, yeah, Micah, Andrew, Ella. All right, and then yeah, you guys are all right, yeah. So all right, Kenny, Nathan, May, yeah, and then Kevin, just let me know if you need any help with this, and I can help you out.
Kevin is my dad, and he is not as his computer right now. So
Oh, okay. Oh, okay. And that, so like can I move on then?
you can move on. Yeah.
All right, thank you. Okay. All right, so now we have run alt mode. So now, if you remember earlier, I talked about the initialization stage and that actual like start or like running stage. So the way you separate these two out is with the wait for start. So just like start typing it and then you can press enter. So you should have this. So basically everything above wait for start is your initialization stage, and everything underneath it is your actual like running stage or start
Is
stage.
wait for start one word?
Yes, it is. Yeah.
And please pay attention to the capitalization.
Yeah.
So in Java, you know how the first word is all in lowercase, and then the second and subsequent words have the first letter as capital. That is called camel case. CAMEL, camel case. And that's how you write methods in Java. So classes should be like how you see first program. You start with a capital letter, and then every word starts with a capital letter. That is how class names are written, but methods are written the way you see it in camel case. And even variable names would be written in camel case, just like the method names. Again, that's just a standard that is typically followed. It would still work if you didn't follow it, but then it gets confusing when you try to remember, wait, is that a class name? Is that a method? And so on.
Excuse me, I have a question.
Yes, go ahead. Yeah,
I'm either
you.
gonna have to share my screen or request remote control.
Oh, yeah. Okay, yeah, here, you can share your screen. Yeah, what was your question? I mean, that looks good, like.
Oh, the first program. Okay.
Yeah,
so
go back to first program real quick.
is this Micah?
No, Andrew.
Andrew? Okay. So Andrew, one quick thing. Yeah, the class name should not be in lowercase. So let's please change first, the F, make it capital.
It'll mess with people.
Okay. So before you do that,
Wait, yeah, I
okay, all right, yeah, you can right click on first program.java and just refactor that there.
I think, yeah, you have to like allow it. It says,
No,
yeah,
you
click-
can say open and
yeah.
then allow it.
Yeah, we had to do this like last count too.
Go ahead.
Alright,
Yep. Oh, it's still doing that. You have to go and check that. Yes,
yeah, there you go.
it should work now. Question mark.
Yeah, just that should be fine.
What if
Yes,
try clicking on the one?
Okay, yeah,
Yeah.
there you go. Yeah, it works now. Okay, so basically,
Yeah, now we are able to control, so we'll go ahead and make the fix. So Ron, you can right click on the tree structure where it says first program.java
yeah,
and refactor it.
yeah.
Rename file. And we'll use that. Yeah. Exactly. Now you have to change that.
Yeah, there you go. Okay.
Okay, just stop
Alright.
remote control.
Yeah.
I mean, that works too.
All right, there you go. Yeah, so now, yeah, you should be good now. So, all right, let me share my screen again. All right, so yeah, everybody should be at this step. And so now we want to actually start like writing our code. So this program, what it's gonna do is just make a motor move for 2 seconds and then turn off the motor. So to do this, first we need to create a DC motor object. So above your @override, you want to do DC motor and then space, and then we can call this like test motor. Yeah, and make sure that you like have it's case sensitive, so make sure you have like capital D, capital M, and over here just like follow the camel case we talked about earlier, where it's like lowercase t for test, but then like motor has the M capitalized. Yeah, so yeah, create this object. And then yeah, I'll give you guys like a few, yeah, just give like a thumbs up or something when you guys finish this. Oh yeah, and also if anybody is having trouble with the import, like if they don't have this import here, just let me know and I'll send it in the chat.
Mine says my DC motor has no usage.
Okay, all right, yeah, that I think that probably means that you don't have the import, so I'll send that in the chat really quick, and you can just copy that.
Mine says no
No,
usage.
my screen looks exactly like yours. It's just mine has no usage over DC motor, test motor, semicolon.
That's
All right,
fine. We haven't started using test motor yet. It's just we just created the variable.
Oh, is there an error? Like, is it red or?
Is it just like
There is red over my public class first program extends linear op mode.
Okay, all right, and I'll just have you share your screen then.
Mine
Yes.
says no usage too.
All right, so
usage error?
yeah, all
The
right. So then
usage,
after,
the usage error is fine, but if it shows a red line, then something's wrong.
yeah, Andrew, do you have like a red line? Is there like a red line?
No, there's not.
Then you're fine.
Okay. All right.
Oh, it's not in team code.
Yeah. Oh,
It's
yeah.
also in a folder. Yeah.
That's why. Okay.
Yeah, we need to move
All right. So, all right. What you're gonna want to do is
Go back to the.
yeah. All right. I'll just like get remote control. I think that'll be a little bit easier. Okay. All right. All right. So basically, this, yeah, this is in a folder. So, that's
I just moved to Java.
okay.
That's a problem. That's okay.
Okay. Yeah. All right. So, first of all, we're gonna want to rename this. So yeah. So one thing you want to make sure that your file, your file name is the same as your class name. So this has to be the same, like first program. Yeah, refactor. So yeah, so you have to make sure those two are the same. And then one more thing is we need to make sure like you put this was not put in, there's the file was not created in the right spot. So we want to cut and then go down, you need to put it in team code, Java, and then under here. So just right click that and paste. Then yeah, refactor. Yeah, all right. And now, all right,
What are those other two?
yeah, I'm not.
On my computer, the DC motor and DC test motor, it's red.
Just delete first. Wait, what are the other files?
I think those are just sample files.
They aren't sample. That's not in the case.
Are you sure this is a sample file?
No, it's in first program. No, those are, but like you see.
You mean, yeah.
in
Yeah.
those, I don't
So
know.
Kenny, how did these two files get here? Do you remember? Kenny, if you're talking, I think you're muted. Yeah,
Maybe they can't mute when you have remote. Just like.
oh, yeah, I'm gonna stop
Don't
remote
stop the share, just hit stop.
control. Yeah, I'm gonna stop remote control. real
I was
quick.
just trying to gain access to my mouse so I can
Oh,
unmute myself.
Yeah, okay. Oh, yeah, I forgot, yeah.
Um,
Yeah,
so, I typed in, the example program from like the first slide. I didn't need, that's why I asked. And I accidentally, made those two files.
Okay, all right, I see.
So in that case, just delete the folder.
Yeah, just right click first program. Yeah, just right click first program and click delete.
Oh,
Yeah. And hit delete.
Yeah, all right, yeah, there you go. All right, you should be good now. Oh, yeah, you should be good to go now. So,
okay.
One more thing, after linear op mode, there's no space between that and the opening curly bracket. Just as a word of advice, it's better to have a space. It's just more readable.
yeah, I'll show you like what I mean. So yeah, you can, if you see here, like, I have a space right here. Just like make sure you have a space there too. It's like, it just makes the code cleaner and nicer to look at. Yeah. All right, so then if
On my computer, the DC motor is red.
yes, yeah, I heard. Yeah, you can go ahead and share your screen now. Oh, let me stop sharing. Yeah, all right, you can go ahead and share your screen. Okay, all right, yeah, that's all right. This is because you don't have the import. So if you just go ahead and look in the chat, I sent an import. Oh, wait, actually, let me check if I did. I'm not sure if I did. Just a second. Oh yeah, okay, yeah, I did. Yeah, so if you look at the most recent message, this
Oh, yeah.
just copy paste that right under your first import.
Under my first import. Oh,
Yeah.
okay.
All right,
Yeah.
did it now?
Okay.
Import. You missed import.
Oh, right. Like that. Import. Yeah, everything's good now. Thank you.
Okay, yeah, you're welcome. All right, so I don't think anyone else is having issues, so I'll move on to the next step. So now we have this test motor variable, or yeah, we have this like DC motor object. But as I said earlier, in the initialization stage, you need to configure all your motors and other stuff. So that's what we'll do right now. So what you're gonna want to do is type test motor equals hardware map dot get. Then sorry, hardware map dot DC.
Will you share screen?
Oh, you need to share.
Oh shoot, sorry, my bad. I forgot.
It's fine.
Yeah. All right, so let me look at this really quick. Okay, yeah. So yeah, so we're gonna need to do test motor equals hardware map dot DC motor dot get, and then in here just type test motor. Yeah.
Will you put that in the chat?
Yeah, sure.
And just to explain what this really is. Now, when you connect different motors and servos and other sensors and such hardware to your control hub, you need to be able to identify each one of them. Because if you have 4 motors, how do you know which motor you're talking to, right? So what is done is you give unique names to each of those devices. So if you have 4 different motors, you can give 4 different names to those motors. So that needs to be done in 2 places. One, you do it in the code, just like has been shown here. And also, you need to add that configuration to the control hub. And the way you do that is you use the driver hub to connect to the control hub. And then in the driver hub, there's an option to go to hardware configuration. And that's where you give a unique name to all the hardware that is connected to your control hub. So this holds good for DC motors. It holds good for servos. It holds good for sensors. And anything else, guys? And then sensors, and yeah, if you have LED lights, then you would give unique names to those also. So just remember that everything that your code talks to, every piece of hardware needs to have a unique name. And that is done through hardware configuration via the driver hub. And when you make the changes on the driver hub, that change is actually happening on the control hub. And your code has to match the exact same word that you use. It is case sensitive and you need it to match exactly. So this is a very important part that you should be aware of. So for example, here you see test motor. That's the name that is being used for the motor, which we will connect and show in this next test or next demo. And so I think Ron's next going to show how you go and configure that in the driver hub so that you have the right name.
I have a question.
All right. Oh, sorry.
The question.
Yes, yeah, go ahead.
What's the light bulb for?
Sorry,
Oh,
the what? Oh, the light bulb? Oh, that's just like, it's not really, it's just.
It's a hint.
Yeah. It's
So what happens is in the IDE, this is the IDE, Android Studio is the IDE. IDE means Integrated Development Environment. And it is set up to give you hints and keep making suggestions so that the way you code something is better. So along with helping you fix errors, sometimes it will give you just hints. Now you can look at the hint and sometimes it makes sense for you to do it and sometimes it does not. So depending on that, you can decide if you want to go ahead or not with the suggestion it's making. In this case, we did not want to move anything out because we have a reason we're coding it the way we are.
Thank you.
Yeah, you're welcome. All right, so now I'll show you guys how you do the second part of this configuration on the driver hub. Click. All right. So you guys should be able to. Oh wait, let me stop mirroring my video real quick.
And I can show the camera.
All right. Yeah, there we go. Okay, so if you guys can see here, all right, so you want to click on these three dots up here, and you want to click on configure robot, which is the third option from the top.
I know it's kind of hard to see. Let's try to find the best.
Yeah, I was gonna say I can't really see.
Right.
Yeah, it's okay. It's like pretty easy to tell like when you actually have the driver hub. Yeah, okay. So all right, so then now if you guys can see here, I already have a couple configurations, but what we're gonna do is press new. All right, so you press.
Keep it without the glare from top. Yeah.
All right, yeah, press new, and then now press zoom in, get it closer. Yeah, and then now press control hub portal.
Ron, do you want to stop sharing so that it's easier to?
Oh yeah. Yeah, and then.
Can you actually go back, hit cancel, go back? And
Yeah,
start
I'll restart.
because this is important and let's make sure everyone's able to see it properly.
I can see really well now.
Okay, great. So we'll go back to the beginning and start.
Yeah. So basically what we want to do is click on the three dots and then, this part is a little bit
Get it
tough.
to show and then.
Yeah, you can see the third option says configure robot.
Sorry, we're gonna try and get it to show. Just a moment. I think the camera keeps changing the auto exposure. That's why.
Wait here.
Is there a way to change auto exposure or turn it off? Okay.
Yeah, there. You can
It's the
see it.
third one.
Yeah, you can see it says configure robot. Yeah. A third one, click on configure robot. Yeah, and then now these two coding camp and minimal chassis, those are two configurations we already have, but I'll show you guys how to make a new configuration. So you click on new and click on control hub portal, control hub. And then now because we're configuring a motor, we're gonna click on motors. And then now here's where you like see based on which port it's connected to, you're gonna want to like make the configuration in that port. So we have our motor plugged into port 0. So we click on this and our motor is a GoBuilda, it's this option basically. And
So
here's
if you're using GoBuilda motors, you most probably have a 5203. So this is the option you would pick. And also one more thing we'd like to add is there are there are web pages which have all these instructions in detail with nice screenshots. And we do have links to those in the last 2 pages. So this will help you follow along, but please don't think that this is the only source you have. There's really good instructions available using which you can do this configuration.
Yeah. All right. So if you remember earlier in the code, we named it test motor, like capital T, capital M. So we want to type that exact thing in here. So TESTMOTOR.
And also, please note that it says 0, port 0.
Yeah.
And the thing is, the control hub has 4 ports, the expansion hub has 4 ports. And the ports are always, port numbering always starts with a 0 in almost all electronics. So it's not going to go 1, 2, 3, 4. It's going to go 0, 1, 2, 3. And if you are using the first port, you're going to use the port number 0 and configure that.
Yes, go ahead, Nathan. Did you have a question?
I just still had my hand raised from earlier.
Oh, okay, okay, all right. So does anyone have any questions at this point?
No.
Okay, all right.
Okay. All right. So then to save this configuration, just keep clicking done.
Can you stop it? Can you go back to that next part? So, you click on Control Hub portal, see how it shows Control Hub. If you had an expansion hub connected, can you ask the in-person people also to watch this, please?
Harry, they should also watch this. It's like important.
So, you clicked on Control Hub portal and then you come in. Right now, we are seeing only the word Control Hub because only the Control Hub is connected. If you connect an expansion hub to the Control Hub, then please remember you have to click on Control Hub portal, come into this screen, and then you will see both Control Hub and Expansion Hub available here. So if you have any motors or other hardware connected to the Expansion Hub, then instead of clicking on Control Hub here, you would click on Expansion Hub, and then that would also have ports 0, 1, 2, 3 for the DC motors and 0, 1, 2, 3, 4, 5 for the servos, etc. So please remember that's how you configure any hardware that's connected to the Expansion Hub, which would be separate from hardware connected to the Control Hub. Okay, all right, let's proceed from here.
Yeah, so then you want to click done and now click save. And here you can name the configuration. So we'll just name this like coding camp 2. Yeah, coding camp 2. All right, and then we'll just click done and okay to save it. Yeah, and now when you have multiple configurations, you just and you want to choose which one you want to use, you just click activate and click this back button and it should go back here. And so now this is if you guys see here, this says coding camp 2. This means that this is the active configuration. So that's good. That's what we want. So yeah, all right. So now we can get back to the code. Yeah, so I'll share my screen again. Yeah, you can turn the lights back on. All right. Oh yeah, so now switching back over to the code. So we have our motor set up. This is good. So then, all right, so one thing you always want to do is the program, it will, especially when you have like webcams and Roadrunner and stuff like that, it will take a while. It will take like a few seconds to finish initializing. And you always want to wait for it to finish initializing before you actually press play. So to make sure that you have waited long enough, we can add some like in telemetry output in the code. No, I'm gonna get to that. Yeah. So yeah, so we'll go back to the slideshow and talk about that. Yeah, so telemetry. All right, so yeah, telemetry, it provides a logging system so that you can constantly see the value of variables throughout a program. So this can help with debugging, tuning, and many other things. So telemetry shows up on the driver hub screen. So if you see this picture here, it's like it says status robot is stopped. So this is telemetry. So that's basically where it will show up. So in a program, you can use the telemetry.addData to add data, and you have to use telemetry.update to make it show up on the driver hub screen.
So think of telemetry as a way to make your program talk to you, right? As it's executing, there's going to be different things that you want to know. You want to know how much a motor has turned, or you want to know what is being detected by the webcam, or you want to know what value the sensor is sensing right now. So that kind of information can be shown on this screen of the driver hub by making your program do that. You're asking your program to take the value of something and show it to you on the screen. So that way you're able to keep track of what's going on. And many times, as indicated there, you need that to debug. Like you want to know if there's a problem somewhere, you're trying to show variable names or trying to show, variable values, or trying to show the values of some sensors and so on. That's one thing. And then while tuning, so in that case, there may be a situation like Roadrunner needs you to make some tuning for which you need to know what values are being shown at a particular point, or what values the motors and other sensors are at a particular point. That's when you use it for tuning. And many other things being like, if you're using TensorFlow to detect objects, it can show you with what certainty it is detecting a cone or a cube and things like that. So just remember that telemetry is a very powerful tool that is available to you, and you should definitely use it. As we go through some of the programs here, they're going to be showing you how telemetry can be used. And there's many more such applications or many more such places where you could use it. Yeah, please go ahead.
All right. Yeah. So now getting back to the program, to actually like code telemetry, you just if you remember, we need to use telemetry dot add data. So yeah, so in this you want to have quotations. So this is your caption. So if we go back to the slide, status and then the colon, that's what was in the caption. So here we would say robot status and then space colon, and you want to have a comma, and now this is your actual message. So for this can be like any type of variable. It can be like a number or like an int value, a double value, or a string value. So in this case, we want it to be a string value. So you want to say initialized. Yeah, and then semicolon. Oh yeah,
and just a reminder, you don't type in capture value. It automatically does that. You don't type that in.
yeah. Caption and value, it just automatically pops up. Yeah, so I'll put this in the chat so that you guys can. Oh wait, actually, I forgot. All right, so then in the slide I said you need to use telemetry.update for it to actually show up on the driver hub screen. So you want to do telemetry.update. Yeah, there you go. So now this code, basically what it will do is when all the configurations have completed on the driver hub, we'll get this message and we'll know that we're okay to like press play. So yeah, so let me send this in the chat so you guys can just copy paste that. Here. Yeah, so just like give a thumbs up or raise your hand when you guys have finished this step. So like when you guys have this coded in. Yeah. All right, Micah got it. And then all right, Nathan got it.
And as you're looking at this screen, just want to make sure you're all aware of one thing here. This word caption and value, this is not something that we typed out there. That's just the IDE showing you and helping you understand that that's the variable for which you're giving a value.
Why are there different colors?
Sorry, say that again.
Why are there different colors?
Oh, do you mean like this comma right here and then the semicolon? You're talking about that?
He means like how purple. So it automatically does that just to make like the thing more clear. So it like makes like variables different colors and functions different colors and stuff like that.
Oh, you said colors. Oh,
Yeah.
sorry. I thought you said commas.
Okay, so the IDE is helping you understand what is a variable there, what's a class name, and where you have the declaration of a class. And some of the words like at override, that's called an annotation. So the color coding is just to help you understand what you're using, right? It could be, and this is something where if you have some very basic Java programs, you can put that into Android Studio and see how it shows you the colors. Like public and void and throws, those are all called Java keywords. And then run up mode, that's a method name. So that's why it's a different color. And then test motor, that's a variable that you declared and you're using that here, right? So when you declare a variable, that variable being used will show up in purple. And then DC motor, that's the name of a class. That's why it's showing up in white.
Thanks. I have one more thing.
Yeah. Please go ahead.
You have to share yours.
Oh, yeah.
Okay, all right. So, all right, so
Like the symbol on row 10.
that, yeah, I see that. All right, let me. Wait, can you talk about this? He's like asking what the symbol is.
Right. Are you seeing that symbol?
No, it's on his share screen. Yeah, I have it too. This thing.
Right. That typically would be the interface.
Yeah. All right, I think basically what this is, it's you know how we did extends linear op mode?
So,
It's-
here, let me explain. So when you have a class that you're declaring and it's extending a superclass. Now, some of the methods in the superclass, they can be marked as required in the sense you have to implement it in the sense you have to have it like this implemented if it is declared that way in the superclass. Now, you could have a method here of your own, which you're creating just for first program. It's not related to linear op mode. In that case, you will not see this. So this simply means this is an implementation of a required method as indicated in the linear op mode. And so if you go to the superclass here, see there's an abstract. When you have a class in which you declare an abstract method, it means that any subclass which is extending that particular class, in which in this case that's linear op mode, is forced to implement the abstract class.
Wait,
I mean
can you-
abstract method.
Can you pause? Well, your last few words just glitched out.
So when you have an abstract method declared in a class, then any subclass which is extending, the class which you have declared the abstract method in, that will be forced to implement that method. And that's why in first program, you need to have run op mode. You could have some other methods of your own too. So like, for example, I could say public test, and then, with no implementation. Okay, I need a void. See, in this case, you don't see that here because this is just a regular method. It's not a forced implemented method. Whereas run op mode, you're being forced to implement that because it's declared as an abstract method in linear op mode. So again, this goes into really the Java side of things. I would strongly suggest, learning Java, including object-oriented programming, where some of this will be made very clear. So we do have a link in the emails that we sent out with the Zoom information and other emails where you needed to do some preparation. We also have these links in the last two pages of the slides, which we're going to share. So it's not specific to like FTC, it's just Java specific stuff. So please do, go through and take that course, which will make more sense on when you need abstract methods to be implemented and things like that.
Because when I click on it, it takes me here.
Right, yeah. You don't have to use that right now because
Yeah, it's kind of just like there. It's not necessary for your programming at all.
oh,
Yeah,
we
you
were
can.
not sharing.
Got it.
Yeah. Alright, so I'll go back to sharing now. Alright. Yeah. Alright, so now we finished our initialization stage. Now we need to code our actual run stage. So for this, it's pretty easy. We have the test motor, which is a motor object. So this has methods under it, such as set power. So we want to do test motor.set power. And now we want to run at 50% power. So this would be 0.5. And so the way power works with these motors is it ranges from values from -1 to +1. So -1 would be like spinning at negative, like spinning backwards at 100% power, and +1 would be spinning forwards at 100% power, and 0.5 is spinning forwards at 50% power. So we want to spin forward at 50% power. So you do .set power, and then now we want it to spin for 2 seconds and then stop. So to do this, you want to use sleep, and it's in milliseconds. So 2 seconds is 2000 milliseconds. So you want to do 2000, and you want to do test motor dot set power and 0. So 0 means it's like no power, so it's stopped. So yeah, so what this program will do is it'll run the motor at 50% speed for 2 seconds and then stop it. Yeah, so I'll put this in the chat in case you guys want to copy paste it in. Yeah. Yeah. So yeah, all right. And if you guys are having any questions or problems with this, just feel free to ask and I'll help you out.
My thing says double power.
It might be because that was selected. It needs to be changed back to set power.
All right, wait. All right, when you say it says double power, like, all right, I'll just have you share your screen.
Oh, that's
Do you mean like what you see on my screen under public abstract void? It says double power. Is that what you're talking about?
No.
Okay, all right. I will just ask you to share your screen.
Yeah. No, just ask them to remove that word and replace it with 0.5. That'll work. See there. Oh, that's just okay.
Oh,
It's
that's
just
just
indicating.
yeah. It's just all right. It's just indicating that like because it's 0.5. That's like a double value. So this kind of just goes back to like Java. So Java has different kind of variables. So int, for example, is like a positive whole number, and then double would be like a decimal value. So it's just float, double or float is a decimal value. So 0, it's just telling you that this is like a double value.
And yeah, going back to the fact that you saw that show up, the IDE is going to keep showing you like hints and other things like that. So as you code more, you will learn to differentiate between what's simply the IDE trying to help you versus what is actually written by you and is the real code. So the double power, that's just the IDE giving you a hint, letting you know that 0.5 is what you have as a value for the variable double power, which the variable of type double named power which is what is needed in set power. So that's an attribute needed by that method. Okay. All right.
Thanks.
Sure.
So. Yeah, let's go back to sharing my screen. So yeah, so just like raise your hand once everybody has this. Yeah. All right. All right, so Nathan, and Andrew, are you guys having any issues or do you just like need a bit more time?
I need a little bit more time.
All right, that's fine. Okay, all right. All right, wait, is anyone still finishing up or is everyone done?
You can copy.
I'm
that.
still finishing up.
So you can copy that.
Yeah, and yeah, Andrew, just in case you need it, I copied this in the chat, so you can copy paste that too, if you want.
I'm done.
Okay, all right, perfect. All right, so now we get to actually run our program. So we'll see an actual motor moving in action. So if you guys remember, we need to click this. So I still have the control hub plugged into my laptop, so that device is still connected. So I just have to click this and now it will be downloading the code. And so, yeah, you guys can see, we'll show you guys like on the webcam how we have.
Can you stop sharing?
Oh, yeah.
So please pay attention to where this.
Sorry, so you guys will see this blue light is blinking. This means that it is, code is being downloaded onto the control hub. And once the code is fully downloaded, we'll see a green light instead of a blinking green light.
And please pay attention to exactly where this cable is connected. You can see, hopefully you can see number 0 there. That's the indication that that's port number 0 in black. And then if you look at the orange part next to it, you will see 1. We have other motors connected to that. Please ignore that. For now, just consider the one motor that we have connected to port 0. And that's this one. Okay, you can.
Mine said install failed.
Oh, do you have, oh yeah, you have the electronics, right? So, all right, I'll just have you go ahead and share your screen. Then it'll be easier.
Right, and for those who do not have the electronics, at this point, please follow along by watching the execution of program here.
Oh, wait, never mind. It just said it did it successfully. I don't know why it said that.
Okay, all right, good. And did you complete the configuration with the driver hub?
Yeah, so my team, we're new this year and we made the Rev Robotics starter bot. So we have the drivetrain and then I just have one of the motors connected for this. So yeah, all the driver hub is all connected and everything and all that. So
all right, perfect. All right, that's good. All right, so now we'll go ahead and run the program. All right, I just remembered I forgot one key step. So all right, let me just show that really quick. So if you can see here, above the class, we need to add an @teleop. Yeah, we need to add @teleop. So basically what this does is if you just look at the video again. You can see how there's two sections. There's two arrows. So everything under this arrow is a teleop program. So you can see that program that we made that doesn't show up because I don't have the at teleop. But once I do have the at teleop, it will show up under this. Yeah, and then everything under this arrow is an autonomous program.
I think since you're sharing, it might be hard to see.
Yeah, it's an autonomous program. So
So
let
basically,
me
you know,
re-download.
the word at teleop, that's called an annotation. And what it does is it's indicating that this particular class or this particular program is going to be a teleop program. Now, if this was autonomous, if it was not tele, then you would use autonomous at autonomous as the annotation. And like Rohan said, this is how you will be able to tell in the driver hub whether you're executing an autonomous program or a teleoperated program. So I think Ron's rebuilding this and he's going to re-download so that it includes at teleop. So all of you, please go ahead and include this at teleop to your program and save it.
All right, so yeah, I think it's almost done downloading. The light is still blinking blue. So I'm gonna stop sharing. Yeah. Oh yeah, so we have the green light. That means it's downloaded. So now if you go back to the driver hub, you can see under this arrow, you can see select teleop, and you can see first.
After you're done with this, will you go back to sharing screen? So I didn't see where to put that teleop.
Yeah.
Sure.
Yeah, all right, it's a bit tough to see, but this basically says first program, so you're gonna want to select that. And now you can see the big.
Yeah, so please pay attention to how it says init after you select the program. So right now, no code has run yet. You have simply selected the program and you have said that that's the one you're going to be running. And it's just showing the init button at this point. And when you click on init, what will happen is all the code that you have before wait for start, all that code will run. So let's see that happen.
Yeah, so basically what it just did is it set up the motor configurations, and you can see our message from earlier has showed up the robot status initialized.
Right.
So this means that we're ready to press play.
So it was showing robot stopped before init was pressed. And once init was pressed, it ran the code and also changed that message to robot status initialized. And now it is waiting at that method, you know, where you had the statement, wait for start. That's where it is waiting right now. So let us see this happen simultaneously. Ron here is going to press start, play, which is start. And then you saw the motor move for 2 seconds and then it stopped. And then the program also completed.
Yeah, so now I'll just like play the whole thing again, and you guys can see just the motor. You can see it spin it, and for 2 seconds and then it stops. Yeah.
So you should run it again, but this time just show how when you press init, the status. Make sure the glare is not off.
Yeah, so it says status robot stop. I press init, it changed to robot status initialized, and I press play, and then it does the motor thing, and then it stops, and it says status robot stop. Yeah.
So does anyone have any questions on this? Was it Andrew or Michael that have the hardware?
It was Nathan.
Nathan, oh, sorry.
Yeah, so Nathan, were you able to like replicate this successfully? Nathan, were you able to like replicate this same thing successfully?
No, my it isn't showing.
All right, like is the program not showing up like on the driver hub?
Yeah, and also the at teleop is red.
Okay, all right, I'll have you share your screen then first. Yeah, so you share your screen and then see. So okay, you just need to capitalize the T. Yeah, there you go. Yeah, just click on that. Yeah.
Click on that, yeah, because O also needs to be calculated.
Yeah, and then just delete the other bit, yeah. All right, and then
Oh,
Yeah,
delete
and-
the extra space also, please. after the
Yeah,
layout.
just backspace, like
after
from
the
right where you
word-
are, yeah.
No, after the word teleop, I think there's an extra space. So please delete that. No,
Do-
if you click, yeah, you can hit backspace once.
Alright, yeah, now, you can download the code again, and it should work this time.
Okay. It's covered up by this thingy up here. Okay, so this button.
Yeah, yes, that button, yeah. Alright, yeah, and then, alright, yeah, nice. So,
Just more. First program, he needs to be captured.
oh, yeah.
Okay, it shows it now.
Make sure the filing matches. Can you minimize the videos?
Yeah, alright, so now you can run it, you can try running it on your driver, like with your driver hub, and it should spin the motor.
The filing, it's all I-
Yeah. So yeah,
I
just
think
like,
shows like a warning sign somewhere.
okay, oh, if it's just a warning, that's fine. Your code will have a lot of warnings. It's just the IDE trying to tell you like a possible issue, but a lot of times it's just, there's not an issue. It's just, the IDE just thinks there's an issue, but
Here, let
if
me
it's a
show
warning-
you.
Let's see what it is.
But yeah, here, yeah, yeah, share your screen. Yeah, let's see. So,
All right, that worked. It's working now.
all right, nice.
Yeah, so.
Yeah,
it's
so yeah,
a
that's
warning
it, yeah.
Because, you have run up mode shows that it could throw interrupted exception. And although it says it could, there isn't really an interrupted exception being thrown. That's why it says that. So that's why it's a warning. It's not an error. It just makes you aware of the possibility you may be missing something or forgetting something. And once you see it, you realize, okay, wait, the reason I'm not throwing it is I don't have code in there which would end up causing that to happen. Now, as you write a full program, it's quite possible that you'll have other things added into the code, and then you may need to throw the interrupted exception, and that's when you would add it. But for now, that's fine.
Thanks.
Yeah, you're welcome. All right, so yeah, all right, so now I guess we'll move on to the next program. So actually, I think this might be a good time to take a quick little break because we've been going for like 2 hours and 10 minutes with no break. So I think you want to take like a 5-minute break, maybe.
Everyone,
Yeah.
please take a. So
Yeah, so it's
it's 3:09 Pacific time. Let's get back at 3:15 Pacific time.
yeah. All right, so it is 3:16, so we will be resuming now. So, yeah, so just like raise your hand or something if you guys are all back at your screens.
Takes away.
All right, perfect. So we will get started now. All right, so basically, I think first off, so we finished this motor program. And first off, I just want to make sure everybody has the @teleop. So like if you don't have @teleop, just unmute and like say something.
So we are starting back now, correct?
Yeah.
Okay, so next you'll show a servo and then use a gamepad control to make the motor stop.
Or it's like later.
Okay, but we want to do that before sensors.
Okay. All right. Yeah. So nobody says they don't have it. So now we're gonna talk about code programming servos.
Can we
So
check with, was it Nathan? that-
it worked.
It worked,
Tried it,
great,
yeah,
great.
yeah. So Alright, so coding servos. So basically what a servo is, the difference between a servo and a motor is a motor, it's like you give it a certain power and it will like start turning at that power. And then you can use encoders. Encoders are basically, it's like a thing, a motor you can use to track how much a motor has turned. So you can use that to basically control how much a motor turns, but it won't be 100% precise. But servos are a lot more precise, but they can't just like keep turning like infinitely. They have a range of motion, which is usually 300 degrees, but you can give it an exact position to go to, and it will go to that position, and it'll even like hold its position. So they're great for turning like small arms and stuff. So for example, I'll show you guys our robot. So let me stop sharing really quick. Yeah.
Nice.
So if you see here, we have this mechanism. This
It's
little-
hard to hear.
Yeah. Oh, let me
Can we, yeah, can you
Put the
put the
mic.
mic to this?
yeah. Wait, can you do it?
I'll do it.
Thank you, guys.
I'll just.
Yeah.
All right. So as you can see here, we have this virtual. It's called a virtual four bar, where it basically keeps this claw parallel while turning. But
the focus is these.
yeah, but what I was trying to say is this is a servo, and we're using servos to control this because servos are so precise, and this is like a kind of thing where you want that level of precision, and like the amount of motion you have, it's not more than 300 degrees, so it works perfectly like the servos.
And you want to explain this also? One more.
Oh yeah, and then this is another servo here. This is a different kind of servo called an axon servo. Or over here we use Go Build a servos. But we use this to control our claw. And this is also because a claw, you need it to like close to a very precise point and open to also a very precise point. So it's also a perfect use case for servos. Yeah. All right, now we'll get back to the code.
This might still work.
Actually, yeah.
And you can ask them feedback.
Oh wait, can you guys still hear me fine?
Yeah.
Okay, all right. All right, so I'll share my screen again. So yeah, so programming servos. So basically, it's very similar to a motor, except first we want to create a servo object. So servo test servo. And semicolon. Oh yeah, and always remember when you're programming in Java, you need to add a semicolon at the end of every sentence, or not sentence, line. Yeah, and I have this error here because I need to import, so I just have to right click. Import class. Yeah,
Show them the import.
yeah, you can see it. Import popped up over here. Yeah, so we need to create the servo object, and down here, we need to do the same configurations as for the motor. So we want to do test servo equals hardware map dot servo dot get, and we just name it test servo semicolon. Yeah, and down here we'll remove this motor
Okay,
code.
hold on. At this point, what if you want to save this code which you just created for first program, you can save that off, so that you can use it to see how motor moves. But there are screenshots of all these in our slideshow, and also as was shown with the sample code, you will be able to find all of this there. But if you really want to make a copy, feel free to copy all of this, create another program called second program or move servo. And then whatever changes you're going to see in this code here right now, you can have just that. Or one more thing you could do, Rohan, is just comment this out. That
Yeah,
way,
if you don't want to do all that, you can also just comment this out. So the way you do this is do a reverse, or you just do this like slash and then asterisk. All right. Yeah, so slash asterisk and then at the bottom asterisk slash.
So if you want to comment just a single line, you can use slash, 2 slashes.
Yeah, so
But if you want to,
so like here, you can
yeah,
just do
if you want,
that.
right. But if you want to comment a block of code like was just shown, that's an easier way to do it.
Yes. All right, so now for the actual servo code, what we're gonna do is make this servo. So servo dot set position. So we can set it to position, we can set it to 1. So, oh yeah, so the way you control the motion is it's like values from 0 to +1. So 1 would be like turned all the way to like one side, and 0 would be all the way to the other side. Yeah, so 1, and then we can wait 2 seconds. Yeah, 2 seconds, and we can just turn it back to 0.
My servo is red.
It's red. All right.
Same.
Might be because you don't have the import. So if you look at your imports, do you have this one right here?
Yes, but it's like faded.
No, mine, I don't have that.
All right. All right. In that case, I'll just have you share your screen then. Share your screen. Oh yeah. So all right. So for you, all right. I think servo was spelled wrong, so I think you need to change it to SERVO. So like change that E right there to an like so S. No, SER. So like backspace 1. ER. Yeah, type ER. Yeah, and then change the E on your right. Yeah, no, on your right. Yeah, to V.
V as in, yeah.
Yeah, there you go. Okay,
And then
press enter.
And then also, just a reminder, it's good practice to name your variables or objects with a lowercase first letter. So test servo, please use a lowercase for that T, and then capitalize the S. Yeah, and then the T, yeah.
Yeah, all right. And then now right click on your red servo. Yeah, and then click show context actions and import class. Yeah, there you go. All right, and then yeah, that's
Got it.
yeah. Oh, and at the bottom, do you see how you have like 2 more of the slash asterisks? You can delete those. So, all right, delete 1 more.
Also was an extra bracket included in the comment.
Yeah, there you go.
Why is there a bracket? in the comment?
Oh, okay, and then, all right, wait, I'm just gonna really quickly get remote control. Yeah, it'll be easier than explaining it.
Yeah, it's an asterisk. and then a
Right
slash.
here, yeah, so right here, your first, okay, yeah, so it needs to be asterisk slash. Yeah, so basically your first part has to be a slash asterisk, and then when you're closing it, it has to be an asterisk and then a slash. Yeah, so just like that. And I'll share my screen again. And I think one more person was like having problems. Who was that again?
That was me.
Oh yeah. Did you want to share your screen?
Well, it's not red anymore, but like the import com thing is like faded.
Okay, do you have two of them? Or, all right, I'll just have you share your screen.
Oh, servo's lowercase in the definition.
Oh, yeah, okay, it's because, all right, so under DC motor, like where you have, no, not there, in your line 12, yeah, go to line 12. So yeah, just change that to a capital S.
And the test servo or the just servo?
Just servo. Yeah, change that to capital S. Yeah, there you go. Yeah, just work on that. And just yeah, just delete that. Yeah, there you go. All right, that should be good. So I'll go back to sharing my screen. Yeah, and then you guys, I'll give you guys some more time to finish up this code. Yeah. All right, so just raise your hand when you finish the code.
Will you please copy and send the text for test servo into the chat?
Yeah, okay, yeah. So I'll send the code for moving it first. Yes, all right. So that's the movement code, and then the code. And then I'll send the configuration code too. So yeah, so the first message I sent is the movement code, and which you want to paste it underneath the commented out motor code. And the second message I sent, which is the most recent one, that's the hardware map configuration. So just copy paste that under the test motor equals hardware map thing. Yes.
Configuration. That way you get practice. So you're going to configure the server on your server statement of the experience.
Yeah, just remember, if any of you need help, just let me know. And yeah, go ahead.
I don't have the test servo that's under the test motor.
Okay, I'll have you share your screen then.
Like I don't have what you have here.
Oh, okay, this is, oh, okay, all right, so, all right, wait, I'll just get remote control really quick. Yeah, so a couple things, over here where you have the hardware map, you don't need that DC motor there because, oh, it is kind of weird. Oh yeah, all right, I see. This needs to be capital M. So yeah, there you go. So you don't need to have another DC motor before your hardware map configuration. And the reason your test servo stuff down there isn't working is because this S needs to be capitalized. Yeah.
Okay.
Okay, just a sec. Yeah. There, yeah. So and then just underneath test motor equals hardware map, just copy paste that other code. Yeah. Oh yeah, so Micah, okay, it's I think it's because your test servo is spelled wrong, like at the top under the test motor in line 11. It's SER via.
It also wasn't it also wasn't hardware mapped.
Oh yeah, that I didn't. All right, Kenny, you're done. If anyone else needs help, just let me know. All right, Micah's done.
Can you check and see if I have the right code? All the code in?
Yeah, sure. Just share your screen. All right, you're really close. You just forgot to do the hardware map configuration. So just if you look at the chat, the most recent message I sent, just copy paste that under test motor equals hardware map dot DC motor.
Yeah, after that line.
So yeah, after that line, just like copy paste that code from the chat.
Where do I put it?
Under test motor equals hardware map. Yeah, there you go. And press enter. Yeah, all right, perfect. All right, yeah, you're good to go now. So, all right. And I'll share my screen again so that the rest of you can finish up.
When it's flashing rainbow.
So when you're, when configuring the try phase, you will give it meaningful message. Right now, this movie has not been really.
Alright, so, oh yeah, I think that should be everybody then. So yeah, just, let me know if you're not done. Yeah.
First, I'm gonna make the runoff mode.
Alright, yeah, I think everybody should be done now. So the next step is, if you remember for the motor configurations, we had to set them up on the driver hub too. So we have to do the same thing for a servo. So I'll stop sharing and we'll go back to the camera. So yes. This, yeah, that, so yeah, so we have to basically go back to configure robot. So yeah, and then yeah, you see we have the coding. So yeah, we have coding camp 2. So you want to press edit. Yeah, and then control hub portal, and then control hub, and then servos. And here, depending on which port you plugged it into, you'll have to like you'll have to like set it up on the right port. So I think we have it plugged into port 0. Okay, we have it plugged into port 5. So we'll do that. And then you want to scroll down and just click servo. Yeah, and then we named ours test servo. So we need to like put that in. Test servo.
Didn't we put the T in test lowercase, the first T?
No, so yeah, that was for the name of the variable. But if you just look at my screen again really quick, and if you see here, this name right here has a capital T. So this is what you want to type into your driver hub. You want to type in whatever you put here.
So please remember, the hardware map is where you're getting the hardware information from. So the hardware map, it's like an inventory of all your hardware, and that is built from what you just configured. You know, the one which was configured on camera. Yeah, that is the hardware map that you're putting together. And so when you want to get this servo from the hardware map, you're going to ask for the name test servo with capital T, capital S.
Yeah.
Got it.
And then you might assign it to another variable, which might, you know, I think in the case of the code, it started with the lowercase t, which is what we want all variables to do, start with the lowercase. But the exact string that was given to the hardware map, that's the one which needs to match.
Why do we want a variable to start with a lowercase letter?
so that you can differentiate it from the name of a class. So class names always start with a capital letter and variable names always start with a lowercase letter. That's just, again, a Java convention. Your code will still work if you don't do that, but these are something called best practices. Like in the software industry over the years, there are various different best practices. Some of them may follow a different kind of protocol. Like instead of having lowercase, capital case, what they might decide to do is have an underscore before every method name or have an underscore before every variable name. So you'll find a few different things like that. And in some languages, they may have M underscore before every method name. That way it's very clear that it's a method name. And then they may have a V underscore before every variable name. And each language seems to have their own conventions. For Java, it's what we have been trying to teach here. With Python, there may be different conventions and things like that. So, yeah.
All right, so now we finished this, so you should click.
Got it.
Okay.
All right, wait, I accidentally clicked cancel. I have to do this really quick. Okay, all right, yeah, there you go. So now click done, and then save. Okay. All right, this part, it's all right. You guys
It's
have already
similar,
seen
yeah.
it, so it's the same thing.
And you don't have to activate again because it's already
Yeah,
activated.
Yeah, so yeah, you can see we have coding. It says the configuration, active configuration is coding camp 2. It's a little bit tough to see.
Oh, out of focus.
Just like
That's okay. I
it's
think
all
it's
right, yeah.
pretty clear then.
Okay.
Coding camp.
All right, so now, all we have to do is just download the program. So I'll share my screen again.
How do you like?
Yeah, so I have to do this, download the program, and yeah, and you see like the light is blinking blue. This means that the program is being downloaded. Yeah.
I think somebody raised their hand. Is that a question?
Oh yeah, or any of the raised hands questions or just like
I think Ella has a question. Yeah. Ella, please go ahead.
No, that was just from last time.
Oh, previous. Okay. Yeah, that's fine. So while that's happening, just showing. So this is what a servo looks like. And you can add different kinds of attachments to servos. And we're just using this for our example here.
Yeah, so now if you look at the driver hub, I'm gonna select first program again, and we're gonna press init. So now we see the initialize message. This means you're ready to press play. So press play. Wait, what?
It might already be in position 0, right?
It's supposed to go to the shot.
Or it might already be in position 1.
But then you should go to see it.
Oh, you need it all. Okay. Let's see.
All right. Yeah, just a second.
Oh, it's connected wrong. The servo.
My servo isn't working either.
So can someone hold this?
Did you?
It just needs to
alright,
flip.
so did you finish like configuring it on the driver hub?
Yes.
Alright, and is it like, do you have any error message or is it just not there? Like,
I can't really hear you that well.
Oh, yeah.
Does your driver hub have any error message? Like, over here, do you see an error message or is it just like not turning?
It doesn't show any error messages, it's not turning.
Okay, all right. In that case,
yeah.
you
So
might have the same issue.
Yeah, we had made a mistake, which is if you see how the white wire has to be on the right-hand side and the black has to be on the left-hand side, we had it flipped. So please check that this is how you have it connected.
Okay, that's what I did. It was the wrong way.
Oh, okay, all right. So now let's go ahead and execute the program. If you can please hold that here.
So, all right, press init. It's ready to play. Press play. What? Okay, all right.
Is it the same program
Plug it in
we
back.
tested? No, that was fixed.
I think it was plugged in.
Is it plugged into the wrong port?
No.
It's on port 5. Yeah.
What else can?
So did you guys try to run it?
Yeah.
It worked? Oh, okay, all right. And it's the exact same program?
Yes.
Okay. So the team that is attending in person, they got it to work. So let's see.
And my servo moved for like half a second and now it's not moving again.
Okay, that is correct then. That is correct. Because when you ask it to go to position 1 first, it might already be in position 1, in which case it will just stay there. And then when you ask it to go to position 0, it's going to rotate around. And you will not see it keep rotating like a motor. It's just going to rotate, once about 300 degrees max.
Okay, yeah, I moved it out of position and then I activated it and then it moved back to
Yeah.
straight
yeah.
across. Okay, so
Perfect.
it works. So
Yes, that's right. So why is our program not working here?
Wait, I'm testing something.
Okay. Anyway, in the interest of time, we'll move along because we know everyone who's trying it on their own hardware, they've got it to work. So let's.
well, it for me it wouldn't move unless I moved it moved it out of position and then I activate it, then it moved back into position. Like it won't move if you leave it like that.
Okay, yeah, that's
Okay,
what-
let's
that's what
try
I'm-
that.
That's what I'm testing right now.
Okay, can you hold this?
Yes.
Let's move this out.
Make sure your fingers aren't in the way.
Sorry, what was that?
Make sure your fingers aren't in the way.
Oh,
Oh, fingers, yeah, oh, sorry, yes. So I'm gonna disconnect this. Move it around.
wait, no. Oh yeah, just a second, guys. The code is downloading. Sometimes it can take a while. I don't know why. Some downloads it just takes longer than others.
It's basically the build time. So after this though, we'll go on because we want to show them how to use a gamepad controller to move the motors.
Wait, what time is it?
It's 3:43.
6:43 Eastern time.
Yeah.
Should I just show you the code on the slideshow and how to get through it?
Okay.
That's what my team wants to do with the controller is to make, because we have a chassis like a tank drive. Like the 2 left wheels are driven by 1 motor and the 2 right wheels are driven by 1 motor. So that's what me and my team are trying to code sometime is a tank drive with the controller.
You show code like that?
Okay.
Yeah.
So, all right, what we're gonna do now is actually, I'll just start showing you guys code. You guys don't have to actually code anything, just watch, because this way we're gonna get through a lot of different kind of programs, including how to program the tank drive.
And all this code will be made available. to you?
Yeah, this code will be made available to you guys.
It's in
You guys,
screenshots.
yeah, so you can come back to it later and use that in your programming. So yeah, so I yeah, all right, here. So coding a motor with encoders. So I talked about encoders a little bit earlier, but they're basically something you can use to track how much your motor has turned. So if you see here, what I did is I created a method, public void move motor to pose, and I passed in an encoder pose. This is just basically if you see I have where my mouse pointer is. Oh, wait, sorry, just a second. Accidentally clicked. But yeah, if you see where my mouse pad is, I wrote 1000 there. Basically what this encoder pose is if I put 1000 there, then in this whatever is happening here where I have encoder pose, this will just be replaced with 1000 when it runs. So what this does is it does while test motor dot get current position. So this is the encoder part I was talking about. So this basically returns a value that symbolizes how much the motor has turned. So then basically it's saying if it's that position is less than 1,000 in this situation, then it will spin the motor at 50% speed. And then once it breaks out of this while loop, so once it is not less than 1,000, then it will it'll stop and so, like by setting the power to 0. So, yeah. So are there any questions?
No.
All right. In that case, we'll move on. So next up is programming a gamepad. So this program will basically like show you how to program a gamepad to like when you move a joystick, it'll make a motor turn. And when you press a button, it'll set a servo to a certain position. So basically what we did is you have to create a gamepad object here. So we called it test gamepad. And then you don't have to like wire this to like the hardware map or anything because you just plug it in directly to the driver hub. So yeah, so all right, while op mode.
Let's actually show them. So please. Please look at the camera. You can stop sharing. So you can see that there are 3 USB 2 ports, and you want to use the right hand side too, right?
Yeah, you can use any of them.
Okay, A, B. Okay, right. So you will be using only 2 of these 3 USB ports, and you will be plugging in the game controller into one of those. And then after that, there's the sequence that you need to run, right? So please remember that the driver hub only supports 2 gaming controllers, and you have the ability to select which one would be the first one and which one would be the second one. So Ron, can you please show the exact sequence of buttons to do that?
Yeah, so basically, yeah, so yeah, so if you want this to be, all right, so you have 2 gamepads.
Nothing selected yet.
Yeah. So if you look up here, you can see user 1 and user 2. So if you want this gamepad to be user 1's gamepad, you have to click start and A, and you can see how that popped up there. That means that user 1 has a controller connected. So that's like pretty important because in your code, that's how you basically distinguish because you have 2 gamepads, right? So that's basically how you distinguish which controls are for which gamepad. Yeah, so you just want to do that. Yeah, and then if I want to switch it to user 2, I just have to press start and B, and you can see how it switched over to user 2.
So please remember start and A for the first and start and B for the second. Okay.
All right, now I'll go back to sharing my screen. Yeah, so all right, so then now back to the actual code. It's pretty easy to like code this. You need a while loop. So this is like when you're coding a teleop program, you're always going to have this while op mode is active. And you need this op mode is active because if you just have like a while loop with like, let's say you just have a while loop and then the condition says like true, then when you stop the program, it could just like keep going. So, but you want your robot to stop moving when you stop the program, right? So if you don't have this, you could have issues with your robot just like keeps moving even after you press stop. And that gets you a lot of penalties in the actual game. So yeah, so that's why we have this while op mode is active. Yeah, so yeah, that's why, yeah, it's while op mode is active. So now in here you can see I have test motor dot set power and I have test gamepad dot right stick Y. So basically what this means is the gamepad has 2 joysticks. So this is gonna be your right joystick and it's like the Y, which means up and down. So basically if you move your right joystick up or down, it will move the motor at that exact power. So we'll show you on the video really quick, just like what that is. So right here, this is my right joystick. So the up and down, so if I move it up, it'll move at it'll move the motor at a power of -1. And if I move it down, it moves the motor at a power of +1. And this is also something to remember when you're programming a gamepad. Up is negative, down is positive, and left is negative, and then right is positive for your X. Yeah. We'll go.
Why isn't up positive and down negative?
I'm not really sure. That's just how they were made. There's no specific reason for it. It is kind of annoying, but it's just like that. Yeah, but you just have to program it around it.
No, that's fine.
All right. All right, so now for the servos, I have in the while loop, I have an if test gamepad.a. So basically what this means is if you press the A button, then it will execute this code, which is test servo.set position 1. So this will basically move the servo to that position. And now if I press B, it'll move this servo back to position 0. Yeah, so are there any questions? All right, if there's no questions, I'll move on. So now, all right, this is coding a touch sensor to move a motor. So it's pretty it's kind of similar to last program because we have this while loop again. This while off mode is active.
So this off mode is active is a very important thing. So please remember that you should have that. It is a requirement because when you stop a program, you want to make sure that there isn't any hardware moving. And if you don't have off mode is active in your loop, it can result in bad situations where you might think you stopped a program, but it could still do things. So please remember to use that off mode is active for all your while loops.
All right, so directional. All right, so yeah, so we have that while loop, and then if you can see here, I made a touch sensor object. Yeah, touch sensor, test touch sensor, and I had to wire this into the hardware map. So just test touch sensor equals hardware map dot touch sensor dot get. Yeah, and then in the while loop, I have if test touch sensor dot is pressed. So basically, what this means, what this is if you press the touch sensor, this value is returned as true, so it will execute whatever is in here. Basically, if we press it, it's true. So it'll make the test motor, it'll set the motor power to 50%. And else means like if it's not pressed, so if it's false, then it will just turn off the motor. So yeah, so any questions about this
I
program?
have a question, but I'm gonna need to.
I think you unmuted. Can you say that again?
I have a question about the code. Can you bring it up again?
Yes. Yeah. All right, yeah, what was your question?
Yeah,
I think you're muted.
you know, like the end thing.
Sorry, say that again, the what thing? Okay, yeah, sure.
Let me show you.
Okay, wait,
He's trying to control yours. I think we need to do it the other way.
No. We need each like
No,
to show you something, yeah. Alright, wait just a second, I'll stop my share. Alright, yeah, alright, you know what, just like try and like explain to me, like, all right, so what are you talking about exactly?
Can you
Andrew?
share my screen so I can show you the thing I'm talking about?
Sure, yeah, here. All right, yes. Oh, are you just like asking why that's not there?
No, I'm asking about the one with that thing with the line next to it. What's that one for?
The line next to it. Oh, that line is just my like cursor.
When you
Like,
took the
yeah,
screenshot.
yeah, when I took the screenshot of this code, it's just like my cursor was on it, basically.
Oh, okay,
Yeah.
got it.
Yeah, that's nothing. It's just nothing special. Just like my cursor. Yeah. Okay. All right. So now we'll move on to the next one. So coding a distance sensor to move a motor. This is very similar to touch sensor. So we have to create a distance sensor object, and we have to wire it in the hardware map. And this is, for some reason, the distance sensor, you have to do it a little bit differently in the hardware map. You have to do hardware map dot get and in parentheses distance sensor dot class, comma, and then the name of the distance sensor. So yeah, so it's a little bit different, but not too hard. Yeah, and then down here in the while, and all right, if you look at the very bottom, you'll see like some like motor code. Just don't worry about that. That was a mistake. I need to change that. Yeah. All right, just look at this while op mode is active. So we have that loop again, and we have if test distance sensor dot get distance. And the nice thing about a distance sensor is you can specify the unit. So we are using centimeters in this example. So basically what it's saying is if the distance sensor is less than 10 centimeters away from whatever you pointed at, then it will set the motor power at 50%. Otherwise, the motor is off. So any questions about that?
So one thing I want to show is like show everyone how to push that code back to GitHub. So, so let us, as soon as you finish this one, let's switch back to Android Studio. Okay, let's switch back to Android
Okay,
Studio.
all right, so we're gonna take a pause from that really quick, and I'm gonna show you something. So, yesterday we set up GitHub, but I still need to show you guys how to actually use that with Android Studios. There's Android Studio. So if you see here, up here, it says Git. So, this button, update project, this will basically like if any of your teammates have pushed any code, like made any changes and pushed it to the repository, you want to click this button, and that way it'll update your program. So this is basically every time you start programming, you always want to press this button. That way it's like you immediately get the updates, and you don't like start coding without the updates, because that could cause issues later on. Yeah. But now let's say you made some updates and you want to push it to the repository. You're going to want to go on the left here, click on commit, and then you can see here changes. So just like click this and it'll highlight that change. And over here you have your commit message. So you want to make sure this is detailed. So for example, we made our first program. So you can say made first program to move a motor and a servo. Yeah, so we can say that, and we can say commit and push, and say commit anyway and push, and you just press push, and it's right now what it does is it's basically updating the changes. So now when one of your teammates pulls, they will get these update changes. Oh yeah, Kenny, I see you raise your hand. Do you have a question?
I was about to ask how to move it, but I found out.
Sorry, what was that? How to what?
I was about to ask how to move it to GitHub, but I found out.
Oh, okay, all right.
I'm curious how you move it to GitHub. I didn't really understand what you were saying.
Okay, all right, I'll repeat that. So, all right, let me just like make a quick change really quick. Let's say, all right, let's say I added a gamepad object here. Let's say I added the test gamepad here. So then now, if you look here, like under commit, it says changes, right? So basically, let's say if I want to like push these changes to GitHub, all I have to do is I just have to select this. So select these, and then down here, this is your commit message. So what this is basically like saying you basically say what you changed or created, and that way when you're checking like previous when people are checking your like history and previous versions, they'll know like what that commit was. So here I added the test gamepad, so I'll just say added test gamepad to first program. So yeah, so now when I commit and push here, and all right, and it shows commit anyway and push because I have a warning. This is fine because as we talked about earlier, warnings are kind of just like trying to tell you something like you might have missed. But in this situation, like we know we didn't miss anything. It's just like the IDE thinks we might have missed something. So you can just say commit anyway and push. And you'll get to this screen and you just click push. And then now if you see in the bottom right here, it says pushed one commit to origin/main. So now if any of my teammates click this button to update the project, and then all right, whenever you're updating project, like pretty much most of the time you're gonna want to select like the merge incoming changes into the current branch. Yeah, so then you click OK. So now if any of my teammates were to do that, they would get all the updates that I push. Yeah, does that make sense? Does anyone have any questions?
That makes sense.
All right. Micah, are you raising your hand for a question?
Yes, I was wondering, is it okay to use parts of the code that you have showcased in these last 2 days?
Oh, yes, definitely. Yeah, you can.
Assuming that we use if that we cite you guys and say that we did get it.
It's fine. This code, we're sharing this code with you guys for your benefit. Yeah, you can use all.
Okay, just making sure.
Yeah. Okay. Andrew, you can go ahead.
Yeah, what's the point of using Git?
Yeah, it's as I talked about yesterday, it's like very important because it allows you to track your like previous versions. So like let's say something goes horribly wrong in your code and it's like it's all like messed up, then you can just like go back to a previous version, and you can only do that if you're using Git and GitHub. And then the second most important thing is it allows you to collaborate with your teammates. So as you just saw here, I made some changes to the code and I pushed them to GitHub. And so now my teammates, all they have to do is just like press the update project and they'll get all the updated information, and they will have like the most up-to-date code. Otherwise, we'd have to like do all the coding on one laptop, which is pretty annoying and tough to do. So yeah, that's the main benefits of Git and GitHub. Does that answer your question?
Yeah, that does.
So now I'll move on to the next program here. All right,
so I know we're over 4 o'clock. If anyone needed to leave exactly at 4, feel free to go out, leave. But I think Ron here is trying to show a few more things before wrapping things up. But if you need to leave, thank you all so much for joining us here for this FTC camp. We hope this has been useful. Please remember, I know you guys got to run a couple of programs or see a couple of programs run, but all this code is available in the samples, and you can look at the screenshots. Those will also help you. We will be sharing this information, both the recording and the slideshows here soon after the camp is done later on tonight. Please know that you will have a lot of code available in the samples, and we are here available. If you have questions, feel free to reach out via our team email. We'll be happy to help. Right.
Will you guys be sharing the video and the screenshot?
Yeah, thank you.
It'll probably be in like 1 or 2 days, I think. So yeah, you'll have it pretty soon. You have to wait.
I meant like where?
Oh, where? Oh, we'll email it to you guys, like the same way we sent the Zoom link.
Got it.
Alright, oh yeah, so Nathan, I know you said you and your team, you guys wanted to like program a tank drive base. So these next few slides here, these are like basically exactly how to do that. So, if you want, you can stay and I can like, kind of go through them with you. Yeah, or if you need to leave, this will be shared. So you can just look at that.
I don't have anything, so I can look at it.
Okay, all right, nice. All right, so in that case, yeah, I'll start going through it. So, all right, so because we have 4 wheels on our drive base, right? Well, most drive bases have 4 wheels. There can be more, but in this case, we have 4 wheels. So,
Do I have to stay?
no, yeah, it's completely optional. You can leave.
Okay. For the one that we have built right now, it has only 2 motors and the motor drives 2 wheels. So there's a left motor and right motor, and left one drives 2 left wheels by a chain and sprockets. So I only have 2 motors.
All right. Okay.
Not 4.
That's fine. That's fine. All right. That's fine. That's you can still program it pretty similarly. So in that case, yeah, I'll just use. Okay. All right. So yeah, I'll just use that as an example. So instead of like right front motor, left front motor, you just have right motor and left motor, I guess. So yeah, you have those 2 motors, and then you just have to hardware map them the same. Yeah, you just have to like, hardware map them the same way we did with test motor. So you can see over here, we just do that. And then down here in the while op mode is active loop, you would have, so here, because we have like a front and rear motors too, that means that we have to have right front motor and right rear motor, but you would just have right motor. So what you would do is you would set the right motor power to your right stick Y, because that way it's like your right joystick would control the right side of your robot, and you would set your left motor power to your left stick Y, and that way it's like your left joystick controls the left part of your robot. That way, if you wanted to go forward, you would like push both your joysticks forward and the robot would move forward. And if you wanted to move backwards, you just pull them both backwards. And if you wanted to turn, you'd like push one forward and push one backwards.
Yeah, that's what we wanted to do.
Yeah. So yeah, so this code will be shared. So you guys can refer to this screenshot here if you have any issues with like setting it up. And
okay.
Yeah. And also based on like which way your is positive for your motor, and like the way your wheels are geared to your motor, your right motor might have the negative, like you can see in here for left motors it's negative left stick Y, but for right motors it's like positive right stick Y. But based on how your drive base is set up, it might be different. So your right motors might be negative and your left motors might be positive.
Okay, I think the left motor is positive because that's the one I used for coding the motor, because I only had 2 and it was already on the drive base, and it moved the left motor forward. Okay. So that's the right way. So positive is the left motor, so the right motor must be negative then.
All right. So
because they're flipped, like because the left motor has a shaft on it, which then has a sprocket and chains that then connects the 2 wheels on the left, and then the other right motor is flipped the other way, so the other motor must be negative then.
All right. So but one thing you have to remember is because the gamepad up is negative, I think it would actually probably be this way, where your right motors would be positive and your left motors would be negative, because like, yeah, okay, all right. So I think you would probably have to code it the same way we have it, because when we coded it earlier, we didn't code it with the gamepad. So
yeah, we just used the button.
So yeah, so once you count for the gamepad, it should be this way. But yeah, all right, that's great.
I can just write it like that, and if it doesn't work, then I'll just reverse it.
Yeah, that's completely fine. Yeah. Alright.
Is that, who are you talking to?
Nathan, because he and his team, they wanted like
Right,
program
understood.
drive based. Yeah, there's a few.
And Nathan, once you try this out, if you have any issues, have any questions, please feel free to contact us on the team email. We'll be happy to get on a Zoom call and help you guys interactively to make
Okay.
sure. Yeah.
Thank
And-
you.
and- No, you're welcome.
Yeah, you're
And this is true for everyone who's on here. As you go through the season, as you get started, if you're stuck or you have any questions, please feel free to reach out. We'll be happy to help. Did everyone get a chance to push the code once to
I
GitHub?
think so. Yeah.
Okay,
I showed them how to do it.
okay, that's good.
Alright, so if you have more time, we can move on to the next slide.
I do.
Okay, alright, perfect.
Yeah, I can stay.
Alright. Nice.
So yeah, we have the fire station for another 19 minutes, so we can go up to 15 minutes. Yeah.
Alright, so if you see here, yeah, this is basically, it's slightly different. So in the other, in our other program, we had like one joystick, like the left joystick was for the left side of the robot and the right joystick for the right side of the robot. But this way of programming is a little bit different because your left joystick basically controls forwards and backwards, and your right joystick controls like turning. So the way this works, it's slightly different, but basically what you want to do is you want to set your, all right, so first off, you want to set your like right motors and left motors to the gamepad left stick Y. But for your left motors, because they're like reversed, it's gonna be like negative gamepad. Yeah, it's gonna be like the negative left stick Y. Yeah, but then to account for turning, you want to use the right gamepad right stick X. So if you remember for the X values, moving the gamepad. Oh wait, let me get it.
Yeah.
I hear you guys. So, alright, so basically, this way, all right, this is our right joystick. So if we wanted to turn right, we would do this. And right, moving the joystick right would be positive, and moving it left is negative. Yeah, so that's something you remember. Yeah, so that's why in the code, we have the right side motors are set to minus the right stick X, because let's say we were to move, we wanted to turn right, we would move our right joystick X like to the right side. So let's say we moved it like to the right by 1, then that means that your right side motors would have to spin they have to spin slower than your left side motors, because if you want to turn right, you need your left side motors to spin faster and your right side motors to spin slower. So yeah, I'm not very explaining it very well. So yeah, Micah, you have a question? Go ahead.
Before we have to go, will you help me troubleshoot pushing some code real quick?
Oh yeah, sure. Yeah, I can do that. Yeah,
Do
I'll
you want to
just,
do that now or finish?
yeah,
that?
we can. All right, I'll finish explaining this thing. Or
Okay.
yeah. We can do it pretty quick.
Okay, okay. So I hadn't been logged into GitHub, so I went and I logged in, but now it is not showing that I am logged in.
So can you call him?
What
Okay.
should I do?
All right, this might take a little bit longer, so all right, I think we'll just finish up the drive based thing first, and then we'll.
Okay. Okay.
And if we're not able to get to it in the next 10 minutes, we can get on a Zoom call separately.
Yeah.
And that was who was
Micah.
Micah had that question. Okay.
I won't be able
Okay,
to.
so, all right, basically what I was saying is, so if you wanted to turn right, it means your left side motors need to move faster than your right side motors. So that's why here the right side motors subtract the right stick X, and the left side motors add the right stick X. And that way, like vice versa, if you want to turn left, then you would be subtracting the right stick X, but the right stick X would be negative. So it's gonna be adding power to the right motors and it's gonna be subtracting power from the left side motors. That's basically how this works. And
Okay.
yeah, and then I think that should be it for coding a tank drive base. Our next slide is like coding a mecanum drive base, so it's slightly different. Like there's a couple more factors involved. Yeah, so Nathan, I think that's you can probably leave now if you want. I'm just gonna help Micah out with his issue.
Okay, thanks for the help.
Yeah, you're welcome.
Okay.
All right, so yeah, Micah, you can just share your screen again. Okay, all right, so yeah, Norman, you wanna help with that?
Okay. So, well, let me try pushing it again real quick. Let me try pushing it again.
So to get to this point, there,
I'm just gonna what's a safe change that I can make to this real quick?
oh, you can just hit enter and add an extra line.
Just hit enter.
Okay, okay. that makes sense. Now I go here
Yeah.
and I hit commit and push. Commit and push anyway. Push.
Yeah.
Okay.
All right, good.
This works too.
You have to click authorize. Click authorize again.
Authorize.
Wait.
Wait here.
Oh. Okay, we gotta use the
Oh,
check.
wait, yeah, go back to Android
Go back to
Studio.
Android Studio.
Yeah, just redo like the push thing again.
Just cancel it or just
And then just like remove the line.
Yeah, just like do another enter.
The line you created, just remove that.
Yeah,
I think this was the line I created.
that's fine, that works.
Yeah. And then
Any line really should be fine.
you have to
You have
select.
to select.
Yeah, select
Oh,
it.
right, so.
Yeah.
Commit and push.
And then this time, when the login thing pops up, click use token.
So click push.
And now
Click
after that, click
use token.
Use token. All right.
Okay,
now
click
go
generate.
to
Yeah,
Google
click
Chrome.
generate.
Or click generate. Click generate. Yep.
Okay. Set expiration to no expiration.
Yeah,
Uh,
Go down. Keep going down. Click generate token.
go back to, yeah, just paste that.
Click login.
There you go, it worked.
And then it worked.
Yeah.
okay. Thank you.
All right.
All right,
Bye.
bye. Thank you for
You
coming.
guys have been absolutely phenomenal over these last few days. Thanks
Oh,
so much
thank
for
you.
everything you've done.
Yeah,
Bye.
we're
Have a
glad
great
we
day.
can help you out.
Yeah. Thank you.
Yeah. Thanks.
Bye.
Bye.
Have a great year.